Good afternoon. You're very, very welcome to Solstice Arts Centre in the second of our sessions on our seminars. The final really gathering, I guess, prompted by there is a forest in my backyard, but my house is built from trees far away. In our first seminar, we discussed the curation and collaborative work with curator Sinjin Walsh and B210 participating Estonian and Irish architects who I know Robert and a number are here today. And a really, really wonderful keynote address, and I'd like to welcome back Shelley McNamara, and it was a really wonderful address with Yvonne Farrell from Grafton Architects, and I want to thank them very much for doing that again. So the second installment is curated by Peter Carroll and looks to future material use. And I welcome again Børre Skodvin of Jensen and Skodvin Architects Norway, Merritt Bucholz and McEvoy, who will give today's keynote addresses, and as well as fellow contributions from Miriam Dunn, Donaghy Dimond Architects, Nuala Flood, Nikolayenia, and Marcin Wójcik. And I really want to welcome and acknowledge the students here today who took time to travel. And I really hope you enjoy the day and discussions, and we'll look forward to robust discussions later on. And of course, really thank you to my great colleague, Peter Carroll, who curated today's session, and always with a unique, collaborative and a vibrant curiosity that's utterly infectious. And all our participating Estonian curators and colleagues, B210, Estonian Association of Architects, the Estonian Centre of Architecture, and our particular wishes go to them I know it's a time of anxiousness for them, just in talking to a number of them on earlier this week. I thank Natalie Wójcik, Vanessa, and the team at the Irish Architecture Foundation, the Arts Council for allowing and enabling us and funding for these seminars to take place, as well as a number of public learning and engagement activities throughout. And of course, the particular Solstice team here, and really they are the backbone of making this exhibition and these seminars really a vibrant, welcoming and a hospitable affair, really. And I particularly want to thank Deirdre Rogers, Nell Keneally, Louise Kieran, Sinead Dunn, Paula Petroska, and Terence Reynolds for their superb work. So thank you very much. And I'd like to hand over to Peter now. Thank you very much.
You doing all right? I'm fine. Yeah. Thanks, Belinda. Yeah. Good morning and welcome. My name is Peter Carroll, and I'm a senior lecturer at the School of Architecture at the University of Limerick. I want to welcome you all here to this wonderful theatre. As I said at the opening seminar, it's one of those formative spaces for me. I met Elizabeth Hatz and many other friends here at the building site when this was being built many years ago, and I'm delighted that Shelley is with us in person. We had this wonderful reciprocal relationship between Shelley and Yvonne and the audience, where they were talking to their own space, which was electric, may I say, and it worked extremely well. I felt it was important to put a coda or a closing chapter to the wonderful exhibition upstairs, which Belinda and her team, as well as the IAF, and we're here today on the benefit of an Engaging with Architecture award from the Arts Council through Fionnuala Sweeney, and only with that facility would we not be here. So I'm very, very grateful for that. As I said, I wanted to look towards the future in many ways, and I'm hoping today we can use the seminar as an opportunity to ask some important questions about how wood might become a greater part of what is a current technocratic state where steel and concrete still seem to play a really strong role. And there's a number of matters I'd like to touch on to do with joints. Now, you might see me hobbling around the stage. A lot has happened in the world in the last 6 weeks, unfortunately. And personally, I've damaged my hip. So you might see me wandering around with the structural joint detail. But it's possibly an opportunity to talk about joints and maybe the spatial joint as well as the structural joint. So I'm sure Børre will give a wonderful introductory talk. The other part that I felt was really important, and it was something that Belinda and Deirdre and Paula and all the team here wanted to push, was the need to involve the Academy of Universities throughout Ireland. And again, like Belinda, I'm very, very happy that there's a very strong presence here from all of the universities. And I know from the audience that we have many of the heads of the schools in Ireland, from TUD, UCD, WIT, UL, CCAE with Anna, and we have Sligo as well with Stally, and I know there's probably a few from Queen's here as well. We've got Nuala in the audience. Coincidentally, many of my favourite people are here in the room today. It wasn't meant to be set out like that, and I haven't yet met Anna or Marcin, who's here for TUD, and Anna's from CCAE. But Miriam Dunn has and is building a wonderful reciprocal structure upstairs in the foyer to the gallery, and I would recommend you all just spend a little bit of time talking to her. She has done incredible PhD research work on timber and has been instrumental in driving timber in SAUL, and certainly heads up a very, very important group of modules called Advanced Construction, Gravity and Reaction, and Environmental Systems and Forces. But hopefully we can use today as an opportunity maybe to have a discussion amongst ourselves and look at the strengths and weaknesses of timber, and perhaps Irish timber. Donal, I see you in the audience there from the Irish Farmers Journal as well, and you're here representing the Forestry Association. Very, very welcome, and very, very happy to see you here as well. So without further ado, I might introduce Børre, and Børre is here with his partner Randy. Børre Skodvin established Jensen Skodvin Architects in Oslo in 1995. Interestingly, Merritt and Carroll also established their practice in 1995. So we might have a compare and contrast, perhaps, by the end of the evening. No disrespect to anyone there in that. I've been a very, very keen follower of Børre's work, starting in 1995 with the national roads works that you did, the Norwegian national roads, and the Mortensrud Church. We have the Tautra Maria Cluster project, which I'm hoping you'll show us, and many, many other interesting projects, which I'm hoping he will show. We've had a very, very special relationship with Børre through UL, and Merritt has been very, very keen to develop that relationship. We've even ran joint electives together, and we've visited many of Børre's projects, and we've visited wonderful works of timber from 10 centuries ago in some of the stave churches, particularly the one in Lomond, which is about 4 hours north of Oslo. And I was thinking it was important to bring somebody like Børre to Ireland again to maybe give us an update on the practices work, but also the attitude to timber, and hopefully we will learn something significant, I'm sure we will, from what you're going to present here this morning. So without further ado, I'd like to welcome Børre Skodvin to the floor. Thank you very much.
Thank you, Peter, and thank you for the invitation. I was very happy to come, both because I really enjoy Ireland. I've been here a few times now, and there's something about all of these communities around the North Atlantic where I feel that there's some kind of shared temperament or whatever, but it's never difficult to be comfortable together with Irish people. So that was very nice. I was hoping for some Irish spring weather, which we also got today and periodically on Thursday. I don't know. Yeah, we have a photograph, and I can see it there. Of course, pertaining in a way to this, it struck me that the English word for timber is precisely the same in Old Norse, timber. which comes from the fact that there has been quite an extensive trafficking across the North Sea for quite a while, giving perhaps an extra layer to whatever we might be able to produce together. I was also quite interested in the topic of this exhibition, because obviously there's this great big movement going on, trying to move the building industry in a more sustainable direction. And always when things or movements like that happen, we tend to see a great enthusiasm for solutions that have measurable short-term results. And using timber is one such option for increasing sustainability, which means that a lot of politicians in Norway anyway have embraced that opportunity, and indeed done a lot of work in order to make it easier to build with timber. But I think the main reason for timber's great popularity in Norway anyway, we have a long tradition of building with timber, but it's the fact that it's a very simple material to deal with. It's readily available. It regenerates itself, more or less without assistance. And it has some characteristics that makes it very, very useful. And all over Norway we find buildings like the ones you see here, that actually exploit some of these characteristics. For instance, this console that you see for the beam in the center of this little storage space. Somebody has found a hooked branch and realized, well, I can make use of that. And then as things have progressed and the industry has become more developed, of course, the formatting of timber has been developed accordingly. And as a result, we are left today with a very formatted industry, relying on pre-cut elements of certain dimensions and certain lengths, perhaps to some extent reducing the space in which we are able to operate as architects if we want to use those types of material. On the other hand, there's been this huge development of technological processing of timber. This is not one of our projects, but it's a project that's interesting, and it's been a reminder to architects in Norway. It's a big bank building in Stavanger, completed recently, and it's really a very, very beautiful project. It's built with a structural system of load-bearing timber, mostly CLT and glue-laminated beams and columns. But it has kind of turned upside down something which we have been seeing for a while now, that there is a tendency to simply replace concrete with cross-laminated timber, and not really asking the industry of timber production to stretch to produce something new, something truly new. This was what happened in this building, which kind of raised our awareness that it's important not to become placid and to be happy that you have a sustainable timber building, even if the architecture isn't all that good. And this is the kind of thing that we are seeing happen quite a lot now. We have buildings where timber more or less replaces, or cross-laminated timber slabs more or less replaces concrete, whereas the architecture doesn't really perhaps benefit or develop all that much as a consequence of that. And then you have, of course, this backdrop of technological so-called improvements to timber. I mean, if you look at timber as a material, it is simple to use at one level, and then at another level it's very demanding to use. And the main reason for it being demanding is, of course, that it behaves erratically. And its behavior depends a little bit on its childhood and youth and environment, not to mention species. So we've developed this whole category of industrial treatments that simply have one main purpose, and that's to remove or at least reduce all of these characteristics of timber that we are not so fond of. The fact that it warps, that it shrinks, that it cracks. So here we have like a whole plethora of different treatments. At the extreme end, you have a process which more or less deconstructs the entire tree and reduces it to fiber, which is then reassembled into something which doesn't have any of the original characteristics of timber, and it's very easy to work with. And then you have kind of glue, lam, and CLT, which are quite moderate changes or modifications at the other end. And in a way, it's a little bit sad because there's things that can be done with these wooden characteristics that can't be done with these types of materials. And to a certain extent, it kind of resembles this very, very sad and dramatic surgical human modification that they were employing in order to pacify wild mines, not all that many years ago, called lobotomization. So it's a pacifying process for timber, making it a bit more easy to work with. Then on the other hand, we have ample proof that timber used in the right way can have an extremely long life. And if there's one aspect to sustainable building that you really want to observe, it's that you need to provide the possibility for a very long life for every building you do, because in the long run, that will more or less null out all those production costs, all the CO2 footprints from the making of the building, and the long life is a guarantee for a good carbon footprint. So we have all these buildings. Very, very fortunate in Norway to have a lot of examples to look at and to follow. And of course, we have perhaps what I like to call the kind of the Formula One of timber structures, the ships. And what's fantastic about these ships is that if you had an engineer calculate them, he would conclude that they weren't strong enough for the purpose. They would not be able to do the job they're set to do. These are boats that are used far out to sea. The boards are half an inch thick, and your life depends on it not breaking apart and sinking. And the only way to develop a structure like that would be through trial and error. And that brings up another thought or another awareness that I think is quite central to this idea of looking forward into timber futures, because we seem now to adopt more and more a dependency towards the predictability of modern engineering, which means that if you can't predict what's going to happen to whatever you build, you won't build it. And if you can't place whatever structure you're working with inside a premeditated kind of model, it's not likely to happen. Whereas this type of thing actually dramatically exceeds the technical capacities of most of the structures we build today, and they are developed through experience. So, and these things are actually still going on today. There's workshops. I was fortunate enough to be able to work at one of these for a couple of months. So, there's this kind of last-minute attempt to rescue some of all this accumulated experience in timber. And it would be very sad if we were to ignore that right now when we are developing our strategies for the future. Because this type of knowledge and this type of skill comes at such a huge cost. So many people need to drown before you can actually cross the North Sea in a boat like that. And these guys are like the last remaining authors of this craft. We've been very, very fortunate in Norway that we've had a few, or mainly one person, very, very eager to record all of these old techniques and collect them in books. So we have a huge repository of traditional knowledge and skills actually mapped and investigated and analyzed. Barns, for instance, very simple buildings and very often disregarded, but are extremely interesting simply due to the fact that in a barn you don't want to spend your best materials and you don't want to spend more materials than you actually have to. And you will find also all the descriptions of how to produce all these. This is juniper branch walls and so on. Even some buildings that very closely resemble some of the buildings that have been recovered in Dublin in the diggings at Wójcik, which you can see at the bottom right here. Post and wattle buildings. So there's all this information to be gleaned from all of this. But the main lesson, I think, to be observed is that timber is not just one thing. I mean, it's all the different species, all the different conditions under which the trees have been growing, giving all kinds of these different characteristics that are suitable for different purposes. And once we decide that we wish to make a greater space for timber in future structures, we need to understand how all of these conditions actually influence our ability to choose the right material. And we need also to look at the industry again to see if is the formatting that we actually devised, 100, 150, 200 years ago still the best? Are rectangular sections of 2x4 or 2x8 still the most interesting type of material to use? Or do we need to check if there are other things we might want to do, which we might be able to figure out based on all of this accumulated knowledge of experience? And one of the things that needs to happen, I think, in order for this to change or develop, is that architects need to become more skilled as procurers of timber. We are the procurers, and the timber industry has a very, very slow turnaround. I mean, if you were to go to the forestry business and say, we would like to have a selection of straight pines, for instance, that are aged around 180 years and that preferably have no dead branches in the first 8 meters of trunk. It would take those 180 years to produce that timber. So our society is no longer set up to make those kinds of decisions, which is a bit sad. But I think, I'm not saying that all timber will have that kind of requirement, but I think that as procurers, we can, for instance, ask the forestry to provide timber that can allow for a reduction in the use of glue-laminated beams, which would, first of all, be much cheaper. Glue-laminated has a cost of 6 to 8 times the price of standard timber, which means that you would get a cheaper structure, but you would also get a structure less industrially processed, and for that reason alone, much more sustainable. So one of the things that we've been experimenting with is bringing the students out into the forest with the chainsaw and the helmet and cutting down their own trees to actually, so that it doesn't become like, the frozen food in the grocery store. You actually know where it's coming from and you know what it does. So I've collected a few projects, old and some slightly newer. Maybe I should have like a clock or something so I can keep track of of time. I don't want you all to miss the rugby match. So just to highlight some of these ideas. So this is dwelling, combined dwelling, and a professional music studio that we did in central Norway a few years ago, inspired very much by these barn structures. It's very fascinating to look at barns because they're so rational and so pragmatic in every way, and also when you look a little bit closer, very intelligently made, in the sense that they have chosen exactly this right type of cheap, readily available timber. And we wanted to see if that could be utilized inside a building like this, which consists basically of the same type of framing that you would find in a barn, making for a very quick construction process. And in addition, using what we now know about how to achieve, how to reduce the heat loss of a building. So the exterior wall is all on the outside of these frames. You can see the consoles here carrying the exterior. And then this kind of jungle-like space that turns up when you go inside, becoming almost like a site or a location where you can more or less decide as you go along where to put the wall and where to put the stair, and to a certain extent we actually did that for this building. But most interestingly, this is not glulam. This is just straight timber out of the woods with its cracks and flaws and everything. Working a little bit to put together a very simple specification for how these joints were to be made. It's a very easy building to make, employing very, very little metal in the joints, because that's one thing that we can see quite a lot in timber structures, that basically what happens when you cut commercial timber is that you cut down a tree, then you take it all apart in order for it to become parts and members that you can put back together again. And you really want some of those strengths and some of the resilience that the natural timber has, but in the process of cutting it, you actually take away quite a lot of the opportunities for employing that in your structures. But by looking again at these old frame structures, we find that they didn't have much metal to enhance their joints with. And the key, of course, is to make sure that everywhere you have a change of direction in the load of the forces transmitted through the timber. Don't rely on a bracket or a ledge or something made out of steel. And of course, it makes for a type of atmosphere or a type of space which has this very strange combination of, we think anyway, of modern and very kind of traditional old school. So it comes across as something which is a very strange mixture of the two. Now, one of the topics that I read were present in the descriptions of this exhibition, and which of course is being discussed quite a lot in relation to this question of sustainability, is reuse, the so-called circular economy or donut economy. There's a lot of words for it, which is simply what happened on its own in older times, not so many years ago, like when I was a kid. You need to reuse as much of the old stuff as possible when you're building something new. And for some time now, we haven't been forced to think like that. But if we were to be forced to think like that again, we would very, very quickly realize that some buildings are easier to use again than others. And the old log building is one example of exactly that. So this is like a modern, these are very, very tiny cabins, built on a steep hillside, as you can see, done basically with a kind of modern variety as a modern variety of the old log house, which would essentially only need to be taken apart in order to be reused for something else. So, and again, the timber is totally is more or less straight out of the sawmill. No industrial. Doing buildings like these, where you don't, we have a slightly colder climate in Norway than you do, and there's always all these issues about cold bridges and insulation and air tightness and so on. And those rules don't apply to this kind of building. So this is really, and that's also an interesting topic for research, I think, to find the cases where you don't have to adhere to this jungle of regulations that we now are facing in our everyday work in order to do experiments that perhaps can enlighten other efforts. So I don't know, should we stop along the way with questions, or will we do it afterwards? Or afterwards, yeah. So just make notes. And then another typical element that you will find a lot in old buildings, and that's becoming hugely popular again today, the wood shingle, which is to be found in a lot of varieties. Some are sawn, some are hewn, and some are simply split from pine, heartwood. This is the last type. And these are kind of re-emerging again for many reasons, but one of them could be that being a very kind of small-scale element, they offer some opportunities for rethinking how to actually use them. If you look at it closely, this is a bit like dragon scales, and you can imagine something very, very curved and three-dimensional, not looking very much like a building, actually being covered by these types of parts. So again, this idea that everything in the future will look entirely different from the past, I don't think that's quite correct, and I think it would be very sad to if we weren't able to rethink some of this these very well tried technologies that we bring along from history. So it's all really about, you know, well, how do we do it? Well, you could do it like this. You could probably do it in many other ways as well, but I think that's one of the most fun parts of being an architect, that you're actually allowed to spend time, and indeed very often being paid to work on stuff like this. And it comes across with, again, this characteristic, which is this strange mixture of old and new, which I think is yeah, interesting, sympathetic, soft and hard. And then you have all this thing about the digital tooling, which is, of course, the big game changer in modern building industry. And I don't think that we have even begun to scratch the surface of the actual possibilities that lie in digital tooling and also digital mapping. Because we talked a little bit about this formatting of the industry and how we're cutting all these rectangular sections in different lengths. And the reason why the lengths are about as they are is because that's when the highest cubic meter price comes out of the forest industry, or that's at least one reason. There's a convention about what lengths you will get. There's a convention about what dimensions they're cut to. And they're always cut on the log to yield the highest maximum output of running meters of the different dimensions that you need. Whereas in a ship, for instance, the old ships, you would generally need to produce everything you needed of materials by hand, which meant that the log was split maybe 4 times, depending on its size, and you would have all the boards with the fibers more or less perpendicular to the surface, giving a very, very strong board, not quite as susceptible to shrinkage and so on as we see the industry producing today. But most interestingly is that this thing that happened when industry came along, where everything that was curved, irregular, looking slightly odd, was ruled out as a source of material, industrial material. That has now changed because we can map all these strange shapes and so on. And I had a big eye-opener. I was in Japan while I was a student, traveling around looking at this, for instance, at Katsura, but mostly because of this big fascination with an architecture that had developed an extremely detailed system of joinery, which is, in fact, a kind of generic system of prefabrication. So they have all these different joints that are well known, and they all have their different purposes and are for the different parts of the house, and every part of the construction is named. And when somebody commissioned the house with the builder, they would draw out the plan with these 1 by 2 meter tatami mats, and the carpenter would do the rest using all these standard joints. So what happens? Japan is kind of a neophile society. They love everything that's new just because it's new. But they also have a deep reverence for old stuff. So what happens when this technology comes along and Japan has to decide whether to reconfigure for that? Well, what they do is they basically continue producing more or less exactly the same system, but with modern tools, which is a very unexpected reaction, I would say, at least compared to what we see here. So what they realize is that, okay, we have a system, it's been working for 400 years more or less, and even more. Why change that? Can we modify it so it can be made in this modern way? And as a result, let's see, as a result, you have this big modern housing industry with buildings looking both traditional and modern, being produced with these exact same, or more or less exact same, this more or less exact same system. So this is something that we were curious about. Now that we have these kinds of tools, can we do stuff that we couldn't do a few years back? And we got this commission for a very small project, really, like making a kind of foyer or central hall at one of these mountain lodges in Norway, 2 adjoining buildings. Not quite, where is the receiver for this? There it is. Yeah, it's in a part of Norway where you generally have a lot of snow quite far out into the summer, so the national skiing teams usually use it for training. And then you have these buildings slightly offset and with levels at different heights needing to be joined. And what we wanted to do was to see if we could develop some kind of prefabricable timber frame structure that was able to adapt to all these odd geometries, using CNC milling as a tool along the way. So obviously, anyone who has worked with triangles has realized that with triangles, you can do virtually anything. I mean, you can kind of model whatever shape or space or form or surface you like. So the triangle is, and also it makes for a very stiff structure. So our main geometrical tool was the triangle, and we went on to model a very detailed view of a 3-dimensional structure that adopted to the different heights and the different plan geometries that we had to meet. Ending up, of course, with this jumble of sticks meeting in a very small area. But with this combination of digital modeling and digital tooling, we were actually able to provide tool paths for a very complex geometry, end surface geometry for all of these pieces, and making a system that would be almost entirely prefabricated and delivered as these triangular frames, but which could be assembled to fit within this rather complex geometrical space that the frames defined. And it was very interesting to realize that you could actually develop joint points at tops of these columns and frames that would lodge as many as 10 or 11 beams coming in from different directions, and all just secured into place with a few screws. So we felt that it was an opportunity which could be studied much closer, because if there's one thing that modernity kind of demands, it's this ability to customize or to adapt to particular situations. The prefabrication process is in itself conservative, and it prefers a case where you can do the same thing that you would do for any other case without changing it too much, because changing means increased costs. Whereas we think that we now have tools and the possibility of production lines that could be very adaptable and very customizable, and this would be one particular take on that. This is of course done with glue laminated beams, because we needed lengths that couldn't be provided, but most of all because we needed an extreme degree of geometric predictability in the structure. We would start at one end and end up at the other, and if you had an increasing discrepancy from the planned measures, you could end up with a huge offset at the other end. But fortunately that didn't happen. And then there's this knowledge about the particular characteristics of different types of wood. And for pine, I would say that the most central thing about pine is the fact that the heartwood of pine is very resilient to rot. And the reason for that is that it's full of toxic resins that have been extracted throughout the years to produce wood tar, which has been used for conserving, well, the Norwegian state churches, the boats, for instance, all kinds of weather protection of all different types of wood. And this is actually a piece of a log from one of the trips with the students to the forest, which I took down myself with the chainsaw. And it was a dry, dead pine tree, had probably been dead en route for 30 years or something. And it was very surprising to find that the heartwood was so intact that it could have been put on a saw and cut up and used for window framing or something. And we started to think about this, why or how could we utilize something like that in order to reduce the need for ever-repeated treatments with oil or paint or whatever. And the case where we got the chance to try this was a redevelopment of a central infill site in Oslo. This is a very old brick building that had to be torn down because the foundations were destroyed by sinking groundwater. And in its place, of course, the owners wanted to realize some of that potential for extra area that the site held. The adjoining buildings were much taller than the one that they took down. And we initially wanted to investigate the possibility of doing the entire structure of timber. At that time, this started around 2014, we still had a situation where contractors tended to price everything made of timber 10-15% higher than a regular structure. Because they hadn't done it before. And also there were some very significant challenges with about sound transmission between floors, because we didn't quite have solutions for that. In the end, we got a regular building, but we said, well, let's at least try to make a timber facade. And let's try to make a timber facade that doesn't, that's not just simply something we stick on the outside, but let's make a timber facade that's timber all the way through, and where what you see on the outside is what you find again on the inside. There was a very fortunate site condition that helped us to argue this particular solution, because it was in a very tight street, a very close spaced, and a regular facade would take weeks to build, perhaps a couple of months, meaning they would have to rent street space, they would have to close off the street for periods and so on, whereas a modular prefabricated facade would only take a few days to get in place. So we started to develop these sets of elements for these different parts of the facade, studying, of course, everything about light and getting in and out to balconies and so on, and also studying how could we set this up so that we have a separate outer layer which we produce entirely from 100% hardwood pine, a layer of cold breaking insulation, and then another layer on the inside which could be regular pine. And how could we develop a facade element where we're not locked to one position of this of the glass, really? Can we one thing that you see a lot in all these or factory developed or producer developed systems for facades in cities today is that things are starting to look very similar, and they all have this kind of flawless glazed outer surface, and they're looking like kind of the ideal model from a fashion magazine without a flaw to their skin. And we wanted to see if it was possible to introduce something which had some of that life that the relief of the older buildings present, where you have shade and light and things going on a deeper level. And it was a very interesting exercise, actually, and we worked together with a company that specializes in prefabricated facades and roofs, and it was very, very interesting to see how they were able to do this in a relatively short period of time and without actually being allowed to do more than one prototype along the way. So, of course, here the main consideration is keep that water out. And I actually, everywhere where you have a horizontal beam and a post coming down on it, there's a potential, rot going on if you can't either keep the water out or have it removed. And at one point I talked to this guy who has done all these books about the old buildings, and I said, well, how do they used to deal with that, for instance, in the state churches? And he said, well, if you look at the sill beam of a state church, you will see that there are these little triangular holes below every post. So what they did was that they made a drain hole from where the post came down on the sill, and that's where the water got out. Now, we didn't dare to go for quite that, so here it's more steel and silicone, but it made a facade which was it answered to this demand for a very quick montage. But the other thing that we got was this. These are just details from the structural setup. But we got this very nice combination of looking at something from the outside, realizing what it is, and then going inside and actually finding again the same thing on the inside. Working also with doors and openings so that we would be able to take relatively small flats and increase the impression of the interior space simply by opening a sliding door. We also had, I had this thing about gypsum board. I really can't stand it. and we had a kind of two-headed client. One was a regular developer, and the other one was the owner of the original site here. And this antipathy towards gypsum was shared by half of the client side, which made it possible to convince them that even though all real estate agents will tell you that people want white smooth interiors with no wood, we were able to convince them that we should try something else. So we got timber wall, aspen walls, and ash floors. And the response by people when they came into those rooms, even if it's a very, very standard thing and not really something spectacular, it was so profound. They were so, first of all, surprised, and they said, it's so nice to be here. I feel I can breathe. And there is a significant difference in this effect that timber can have on interior air quality, simply, just because it lets off humidity or absorbs humidity and regulates the interior climate. A short look at this house. This is a summer house on an unspecified location in Western Norway. And again, a client very, very interested in architecture, and one of those who will employ an architect and actually trust the architect, trust that the architect knows about architecture. Not all clients do. So this started out as a very simple idea, really. It's on the verge of quite a steep hillside, and there's this big pine forest. So we proposed that we could build a kind of foundation for an elevated floor, where we could have all these wings and rooms developing between the trees, and then at the back it would be anchored against the cliff, with the cliff, part of the cliff coming inside the house. I include this not because it's a very kind of, there's timber here as well, there's concrete, there's steel, and that's also, I think, an important point for us, that we don't be prejudiced about materials. Some architects will only build with timber. They are developing forms of concrete that are much more sustainable now than they used to be, and the same goes for steel. And I think that it's like we touched upon initially in the introduction today, the lifespan of the building is perhaps even more important than precisely which materials it's made from. And I think it's an important point to make, that you need to, the main thing is that you need to understand the materials and the potential of the materials in the structure in order for you as an architect to realize their full potential. And in some cases, like in this case, we needed the whole palette, we needed the full spectre. So here again you have these split shingles, and they even split a corner shingle. So it's split kind of around the corner, so it's actually totally watertight on that side. And then another aspect to this discussion of sustainability: how much destruction do you cause on the site in making the building? Most modern contractors will prefer a big hole, a lot of gravel and concrete, and then kind of patching it up afterwards. Whereas here it was of key importance to destroy the site as little as possible, meaning we had to come up with structures that had the kind of tolerance you need, because you don't know precisely where the rock is. We actually were contractors for this project ourselves, because it looked strange, and all the bids we got were at least double of what they should be. And this led to some interesting consequences for us. We ordered materials before we were totally finished with the planning, and the steel beams you see here up in the roof, these main steel beams, are made from square hollow profiles that we actually had to use for something else than what they were intended for, because the dimensions turned out to be too small for the columns as the house grew, and they're kind of reconfigured into some kind of triangulated beam, so to speak. So, and that's another aspect to this building. It's made very much along the way. As we went along, we saw that, well, here it has to be like this, and there it has to be like that. So it was constantly changing until it was actually finished. But that's perhaps the only possible way to do spaces like this. I mean, this old investigation that architects have been engaged in for through the ages. How thin can that membrane between your protected indoor and the unprotected outdoor be? I mean, how invisible is it possible to make that separating membrane? And this was another look at that particular question, with this glass wall that's just embedded in the rock. But all of this is really, in a way, traditional stuff. It's beams and columns and posts and slabs and sheets and whatever. And then you can use it in a number of different ways. But we've always been very fascinated by this idea that the tree as entity has a potential which we are not even getting close to realizing the way that we use it today. So we've always talked about the possibility or finding the opportunity for actually looking at whether it's possible not to take that tree totally apart. And then we found, or paired up, or were found, whatever, by this client who owns this place, which is another one of these mountain lodges. And this is very close to Norway's highest mountain. So this is a starting point for hikers who go up there. So there's a lot of people spending the night and eating their meals there and so on. And this is all a very traditional facility, but at the end of this building you see the two-story building in the center of the picture. They wanted to do an extension, like a eating hall, a dining hall, or where they could have all their meals. And this is in a part of Norway where you have a lot of very, very beautiful pine forest, which is not this type of pine trees that you perhaps see more often, with very tall branchless trunks and a small crown at the top, but huge, big trees growing straight out of the ground. So what we said, well, what if we were able to cut down some of those really beautiful pine trees with all their branches in all directions and bring them to the site and use the whole tree? Just cut it appropriately in order to provide the basis for some kind of roof structure. So this was our simple proposal. We get some trees that have kind of the right configuration of branches. Then we cut them according to where the roof will be. And then we create a kind of stiffening layer or web where the roof is. And this was actually something the client was very positive to. They really wanted to do this. So that led us on this big search for trees. So we were prospecting trees. We have a huge gallery of tree portraits, but they were all more or less like this, really big old pine trees with branches in all directions. And, you know, very, very beautiful. And in a way, a little bit sad to take down, but then again, offered a chance of a very, very long life, hopefully, inside this new building. So we settled on a few of them, 7 altogether, and removed all the stuff that we weren't going to use. And then this guy brought out his big equipment, and they actually were able to cut them down as they stood. and bring them in one piece back to the farm. So it was a kind of surreal show going on. I'm glad they didn't meet any other cars. But it was really fantastic, and after that, of course, we had to remove the bark, because between the bark and the wood, that's where everything happens, with insects and so on. So we used just high pressure water to remove the bark, and this, of course, reveals these really, beautiful bodies. And it's almost like some kind of arboreal pornography, but they're here all naked and with no clothes on, but their bodies are really, really beautiful. And this is a project that's been going on for a while, and we haven't started putting up the trees yet, but I'm just telling you the story because I think it's an interesting experiment. We scanned all of the 7 trees, digitally, 3-dimensionally, so we could work with them as 3D models, and also we could rapid prototype them, print them with a 3D printer, and start working with this in a scale model, giving us the tools to finish more the details of this roof structure. Of course, this is a type of structure which is very, very difficult to bring an engineer along on, because he will have all these reservations about, again, this predictability. So our idea was simply that if we were able to make a kind of web attaching to the top of these branches where they were cut, we would essentially have tensional stresses throughout most of the structure, and the trees would stabilize each other and so on. We're not quite, we've not quite finished the discussions with the engineer yet, but we're getting there. There might have to be some crutches here and there. We don't know. We hope not. But it's in a way, it's taking when I was a student, one of our heroes was the German architect and engineer Frei Otto, whom you may know, and if you don't, you should definitely look him up. But he always said that, what is the best thing you can do with a tree? And nobody knew the answer, and he said, nothing. And it's a bit pursuing this idea. Is it possible to do very little? And this, I think, it kind of shows that digital tools and digital tooling combined with a very simple, low-tech, old-fashioned approach does have some potentials that we are not really digging very deeply into yet. Here we have the plan at 2.1 meters. We can actually predict that where you will bump your head, and I think there's a lot to be studied in this very potent combination of old and new. So here we have the layouts, the engineers' layouts of the roof web, which we have the circles are all the tops of the branches, and then you have this kind of haphazard 4-layered structure of timber members connecting all of this together. This is not showing all of the building, but the building will have the timber coming down to a level of a door height, and then it will be totally open under that, and no posts or columns in the exterior wall below that. So this is all, what it looks like right now. And then this system of joints in order to be able to put all this together in a sufficiently flexible way. So here you see the 4 layers. So it's actually becoming almost a bit like a space frame at the top, because the engineer's a little bit worried about the glass cracking and so on, because you might have movement, but we were getting there. So this is what it looks like right now. But all of this brought back to mind a very, very beautiful little text that I read, which is from, again, these old Norse texts. as you get older, you tend to become more interested in history. And I've lately become very, very interested in Norse language, which bears a lot of resemblances to English, modern English. And there's a lot of words in modern English actually coming from that period of a shared North Atlantic language about 1,000 years ago, where you could go from one country to the other and be understood. But they have this huge volume of poetic verse, and they have a verse about the pine tree. It's used to. There's an English translation below, but it says "Rørnar þöll, sú stendi þorpi á, hlýrat henni börkurni barr, svá maður, sá mangi ann, hvað skal hann lengi lífa?" And all of these trees and all these pine portraits and their naked bodies lying on the farmyard kind of brought all this back. So anyway, that's all I thought I was going to say. Do you have any questions?
Børre, that was extraordinary. I feel inept listening to that, but it was so well put, so pragmatically put, from talking about lobotomized wood through to the simplicity and pragmatism of barns, to the need to understand experience and to take risk and to try and counter predictability in some ways. I suppose, as somebody who teaches as you do and have for many, many years taught in university, I'm interested in, I suppose, bringing that to a stage where this is not a mystery, but it's allowing for students to be able to understand architecture through an inherent understanding of construction, through experience, through knowledge, but also through risk and experiment and understanding potential. And I feel our curriculum is not doing that for many, many years. And I'm just interested, like you've taught for many years in Ahu, and you were the head of the steel workshop, interestingly, rather than the timber workshop. But can you maybe say, like, you have such a very broad understanding of the culture of material, and I'm as interested in the structural logic as well as the spatial logic in this. And when you think about timber, you think about the joint straight away. And I was very taken by your process of work, particularly how you start with that beautiful connected building in the hotel where you've got 7 or 8 timbers coming together and they meet at surfaces that are all splayed. How does one begin to teach that? Or how does one, like, it's mind-boggling in many ways, but at the same time, it's so pragmatic and straightforward. But it does involve risk.
Yeah, I don't know. I think it's very much about realizing that you haven't heard the whole story. I mean, if you're a student and somebody is telling you that this is the whole story, they're lying. It's not true, and kind of opening that door and starting. Constantly to think how can this be done differently, and doing that with an understanding of an original purpose or an original intention, like for the tiles, for instance. It's a very simple principle. You have one tile above the other, and they're all covering each other, and the rain will run off. It won't get into the house, but it doesn't stop there. I mean, you can do a lot of other stuff. But when it comes to the more spatial part of it, I think it's very difficult to discuss because it's very, I don't know, perhaps intuitive at the level, but there's certainly something about, for me anyway, perceiving space. And I find it very different to be, for instance, in a space like this, where you have there is an inherent possibility to understand how it's all put together, and it's readable in a very sympathetic way, but not in a way that is obvious. I mean, it isn't obvious that there should be a diagonal stair going down the center of the space. It isn't obvious that you should have the separation between the steeper and the less steep side like this. The normal way would be to have something not so steep down here and something a bit steeper at the top. So, I mean, why is it like that? I don't really care, but I like it. and very often it just boils down to that. And I think in teaching, I think there's kind of like two parallel, or in studying, there's two parallel tracks really to follow. And one is about learning how to do stuff. And that's in a way only a matter of spending enough time and doing stuff and learning how to do stuff that way. And then there's the other track, which is about finding out what do you like? What do you prefer? What's your affinity? And if you don't, first you have to understand what that affinity is, and then you have to dare to use it when you evaluate whether you're going to do one thing instead of another thing. And you know, when you're looking at structures and materials and so on, there's always a finite amount of answers to your questions. There could be 10 or 5 or 3 or 50, but if you look at the other thing, how do I prefer that this should be? There's like an endless number of possibilities. So that's why I think that it's maybe the one thing that hopefully happens while you're in school, that you start to develop an understanding of your affinities and also learn to trust them enough that you actually dare to let them guide you.
Yeah. And can I dare ask another question? I mean, in Ireland we have a temperate environment, temperate climate, where trees grow much quicker. Like if you think of all the pine trees or Sitka spruces or all of those timbers that are commercially grown, one could easily say that because we have juvenile timber, it's adolescent, it doesn't grow to a full adult. It's kind of cut and produced, but we have a very rich joinery history, whether it's through furniture or through church roofs from 17th, 18th, 19th century. It's very easy to say that in Ireland we can't have these kinds of structures because we just don't have the timber, which I don't agree. But in Norway, where obviously the climate is a little bit more extreme, your trees go slower, you have much greater capacity with timber, perhaps. Maybe I'm wrong to say that.
No, probably you're right.
Yeah. But there is a need for an intelligent approach to this. And like again, with Donald in the audience from the Irish Farmers Journal and the forestry industry, we do need, as procurers, as you very rightly said, we really need to push.
But I think that you also, every region has to realize their potential. And the potential of this region probably isn't huge pine trees. Because like you say, they grow too fast. But then again, knowing about the characteristics of these trees and the characteristics of the timber, you will learn that for the pine tree and for the spruce tree, the winter wood is hard and the summer wood is soft. But for many other trees, that's not the case. Like for beech or for oak or for ash, for instance, there's a lot of ash trees in Norway. It's not being utilized very much. It's used a little bit for floors, but the ash gets harder the quicker it grows. So there's a lot of trees that you could grow that are straight and long fibered and perfect for structural purposes. But it's a matter of daring to not just do what everybody else is doing. So if there is a lot of ash, well, why don't we harvest it? And you mentioned, or did you, bringing the students out into the forest, and I did too. And this is an example of somebody going against the current. The regular norm is that when you buy timber, you buy huge volumes of something which is pre-produced. It's not a specific order you made. And then as it got more and more difficult to find small saws that could provide particular qualities or particular species, there actually was a new space for a small industry. And this is one example of exactly that. So what they did was that they had this forest, and they supplied a little bit for lumber and a little bit for the chemical industry. But they had all these edge forests consisting of birch and aspen and ash, and they were cutting that for firewood. So they rigged this huge setup where they could provide firewood. And then at one point somebody said, an architect came along and said, well, I see you have a lot of aspen here, and I would really like to use that for some indoor paneling. Do you think you could take aside a few trees and sell me that? Yeah, sure. And then this was built, and some people saw it, and they turned up and said, well, I saw this aspen panel. Do you have some more of that? And I was one of them. And then suddenly there's an awareness that there's something that we're currently burning that we could be using to build. So,
very good.
I forgot your question now. But
No. I think you've answered it tenfold. Okay, thank you. Welcome back from lunch, and thanks again to the Solstice for providing that. We have 5 consecutive speakers now, and each speaker is going to speak roughly 10 to 15 minutes each, and we'll try and keep it concise. We're going to begin with Miriam Dunn, who is a PhD candidate and a senior lecturer at the School of Architecture at UL. Miriam has been ingrained in timber technology and has been at the forefront of everything that we've been doing in the school to do with that. So, Miriam, it's great to have you here. That's going to be followed by Will Dimond and Marcus Donaghy of Donaghy Dimond, who are teachers in UCD, and they run their practice in Francis Street in Dublin, a very careful and considerate practice that we would all obviously know of. That's going to be followed by Nuala Flood of Queen's University Belfast, Dr. Nuala Flood, dare I say, sorry, apologies. And Nuala is going to talk also about timber technology there. That's followed then by, we have Marcin from TUD Dublin. And I was speaking to Marcin over lunch there. They have a fascinating program of carbon cycle and how they teach that to their students. I'm looking forward to hearing what Marcin has to introduce. And then we'll finally close with Anna from CCAE. Anna is an Estonian, as far as I know. Russian, Belarusian. Oh, very good, very good. And Anna actually helped one of the practices upstairs with their exhibition. So we'll maybe get each person to introduce themselves as they come up. I might give my hip a rest and maybe take it from there. And we'll try and keep it short and concise. So Miriam, away with you. Thank you.
Thanks very much, Peter, for those very friendly and welcoming words. When I saw the photographs go up of the work we did in SAUL, I suddenly realised, oh my gosh, that's 10 years ago. And it was like looking at the greatest hits on your back catalogue. So here I am on stage singing the back, singing some of my favourite hits. And just speaking on behalf of SAUL, I am part of a team. I am not an individual researcher on timber. So but I'm very fortunate in teaching at SAUL that I've always worked with an engineer. And all my colleagues around me, Peter, for example, who taught assembly and techniques, and Graham Petrie, who taught environmental systems and forces. So just to say at the outset that that's really important to both my teaching and in terms of what you'll see in terms of some of the images from the work of the students. And then there's another thing that kind of dawned on me recently is that, you know, the amount of intensive hours of teaching and research in a design studio, which can take 9 hours, and then by the end of the day you're falling flat over yourself, that's actually just live research. And we shouldn't really call it teaching it per se, because it's this constant interaction and iteration of what the students are doing and your input, and not as so-called experts, but also engaging in the experiment that they're actively engaged with. And I think Børre's point about education on ready-made architects is extremely relevant and vital and pertinent today as we face so many crises. So just to say, that's kind of part of my talk, to kind of give a sense of how research, and the 3 images there are kind of 3 images that aren't equally weighted, but interacting and interrelated with each other. So, and just to say also, I come from the family of Grafton architects, and just very, very delighted to meet Shelley here today, just to give some insight into where I'm from. And then I have a practice in my own house, which is the middle image there, with my husband, who's becoming an assistant architect by default. Okay, so how do I put on the slides? Just the next button, yeah? Okay. So teaching, practice, research, I just chose those 3 titles. And again, because the brief, I thought, oh, fantastic, I'm going to represent SAUL, but I just thought, okay, the brief is open, and Merritt said, bring down your model that you're working on at the moment, which is a 1 to 10 model of a reciprocal frame structure that's a hybrid reciprocal frame structure. But I'm doing a conference in Denmark, and I had to figure out a way to transport the model. So Miriam said, make it 1 to 10 and disassemble it and reassemble it. So in that research process, I was also thinking about kind of, well, how do we approach building today? Maybe it is all about assembly and disassembly, and buildings are being demolished in front of our eyes, such as the TU Dublin Kevin Street project, and becoming hills of rubble. And it's just, that also kind of is a startling thing to face. And then we can look at timber as something where it is about the joint, and it is about assembly, and it is about engaging with that process of assembly and disassembly. And anyway, that's kind of full circle to those 3 images on the screen. Just to say, the first image is the design studio in SAUL, and I think it's a kind of really relevant image because it's like all the research, like a smorgasbord of, I'm thinking of the Swedish smorgasbord where you see all the delicacies and delights on a table. Anyway, when we mounted the exhibition of all the research done in 2011 in SAUL, it ended up looking like that. And we had a really good day, I'd say, with about 8 people standing around that table talking about timber and structures. So I'm just going to pick 2 particular projects of that batch. They were precedent studies, and we decided to engage technology in the outset of the design studio teaching, as opposed to usually you engage with technology after your design project is finished, if anyone's familiar with how architects are generally taught. So we just, in 2011, did the reverse. And we said to the students, engage with timber as a technology, look at the joint in detail, which are all the images on the right, and look at the, is it a form-finding system based on the joint? So those students did the precedent of the Shakira Band Pavilion, but like they made every single element in two people, and it took about a week to, well, when I say start and finish it, but like to finish and to make that beautiful wave pattern, and then to study the light as a result of that form was an absolutely, I mean, the image is beautiful, but it doesn't give justice to the students' actual participation when you see the finished image. So, but the photographs on the right are the students' experiments in making the load path and making the joint that would basically, it's a pavilion, so therefore there's no foundation. So again, the kind of intuitive nature of figuring out how load is carried to the ground is something that kind of also in timber becomes, really interesting. The other thing we found with this 2011 research was that you can actually model timber structures statically and behaviorally to behave like they do in reality. So the timber Gritschel by Frei Otto here, which is the Mannheim pavilion, again a pavilion that's not fully environmentally controlled. And the photographs on the right-hand side are the students' models, and the photographs, well, the top 2 on the left are the real building, and it's actually impossible to tell the difference, which is a stunning achievement. So, Børre mentioned Frei Otto, but like Frei Otto took a timber, he did take the tree apart, Børre, and he did make a building out of very thin timber slats, which were so thin that they flexed and bended with their length. So, but he could create this huge span by just putting a grid of those slats together, pinning them at the joint, and then the student, you can see in the photograph outside, put pins at every single intersection point, and then did that form-finding process that you see there. Then he also experimented with the light. You can see from top to bottom. There's skits and paper used, for example, to modulate from the blue sky. And just to say, it's very hard to get that form finding in the joint. The timbers become really stiff when you make it at 1 to 5, and that was also just an interesting kind of realization for the student. the different scales and how you can understand technology at different scales. So then the next year we said, okay, well, the precinct was kind of a year-long process, so that we said, make it a design problem. Timber as a design problem in the studio, again with intensifying the technology modules, but rather than just through precinct, but just through a kind of proposal. So these students made a proposal for a plated truss out of plywood in a roof, and 2 systems. One was in flat kind of truss scenario, and the other one was actually looking at flat planes that could curve to make arches, but again out of small panels that were joined together. So, and you can see, I cropped out the faces for GDPR reasons, but the student is obviously the feet on the left and the lecturer's the feet on the right. That's Graham and that's Adam. What was fantastic though was they started to experiment at 1-to-1 and started to actually stand on the models and to try and break them. Now obviously you can't break that model because it's on the floor, but still it was a first step. And I remember the engineer Tom Grove walked through the studio and he said, do you know, this is the first time I can really think I can work with architects because the trianguli is statically determinate, and I can, you know, get my engineering students into the architecture studio and we can analyze this model. And he was just, it was a wonderful moment in time, but yeah, let's get the engineers back in the studio is what those models say. So then I got married and had a family, and then neither here nor there. This is jumping into the present. So this is 3 years of a cycle that we call age, and Peter alluded to earlier where it's assembly, gravity, environment. I pulled out the images that related to timber, and just to make the point that the intuitive nature of making models and exposing timber, like in the Georgian house, as Peter said, you know, we're building, there's a lot of timber structures, but they're all hidden behind plaster, so we decided to unpeel the layers and make timber joists and timber trusses in a kind of a group model, and then working drawings and just pulling out details and load paths, like that's the Schindler house in the middle there at the top, and moving from a cycle of 3 years of, let's call it technology, and into the final kind of synergy year where we say to the students, you've looked at all these materials, but what if somebody said, we can't build in concrete, we can't build with masonry, what would you do? How would you approach a kind of building technique that just spoke about timber, or about carbon sequestration, or all those issues that we talk about? So that student took, we looked at an existing building on campus and reimagined it in timber, and we kind of still, that was the first iteration of that project, so that student just decided to shorten the span, put the timber closer together like joists, make it into a truss, use very simple joints, but kind of create, I suppose, using the same, making a reduction in volume because the span depth is lower. And all of these issues that come up in the discussion, and we're going through now in the current third year, another iteration of that timber question, which keeps us challenged in a kind of design thinking. And again, it's always working with an engineer. So I was talking to Shelley at lunch about reciprocal frames, and this is part of the research that kind of, again, is a snapshot of research, but in the 16th century, when they didn't have long enough timbers to span, they had to look for other ways to do it. So the reciprocal frame was one way, because there's mutually supporting beams, for example, that work together to create longer spans. So that principle is actually, I think, becoming relevant today, and even relevant to the over-reliance on lobotomized timber that Børre mentioned. So the other image on the right is the Zollinger frame, which is again a reciprocal joint because it's a simple two-way joint as opposed to three. Short members to create long span, and also because there was a shortage of materials and housing in a war scenario, actually it just dawned on me last month that this Zollinger method uses, well, I read it in a research paper, uses 45% of the material than a standard construction would have in 1920, whatever post-war date. I can't remember the date. I think it was 30s or the 40s. No, it was between the two Great Wars. So that's an astonishing fact that you can create the same span with less material, simpler joints and shorter members. So now this is like a Janus moment because, like all research, you look back and you look forward. So when I was making a design for my own house, I've thought about using the short beams, and I thought about stacking and layering to create a kind of, where you don't have to have temporary supports to hold up a reciprocal frame structure, and then you can use the primary beam then to kind of allow control of light, a layered structure effectively. So then I looked at the fact that you can pre-assemble it dry, and that's actually pre-assembled in the front room of the house, and then assemble it in situ. And the builder's doing his own load test there in orange. And then the multiple kind of variety of light patterns then throughout the day and the year is just something that I became, I suppose, interested by. And then suddenly an opportunity came up to come up with the prototype structure for a conference. It was just a brief. So I came up with 2 prototypes based on those principles, and of the short members and longer spanning. So anyway, the 2 prototypes ended up being stacking up a housing unit, which became really, lended itself well to the program of living and sleeping. And then a multi-layered hall space. So again, just looking at adaptability, flexibility, the tessellation pattern, how it can be repeated, extended, and with multiple opportunities for voids and light, you can actually stack multiple floors, extensive roofs. So it was a kind of a moment to push those ideas forward into another type of program, and another kind of thought about material efficiency, and the fact that maybe looking at that structure, okay, built without temporary supports, but maybe 70% of it could be built with natural wood because the short beams are so short, etc. So this is the beginning, I think, of something that will keep going. And I just have a video of the assembly, which is the model is upstairs. Does it press play? No, I don't know how to press play. Does it play on its own? Oh yeah, there it is. The thing is, it is a bit edited. There is a specific sequence of layers that's actually missing, but spot the difference. And also thinking about the joint as well. I mean, you could probably, the Sherpa joint there kind of is a dovetail joint, and I know it's metal, but you could possibly see mill a dovetail joint now out of hardwood, and this is built in beech. So again, looking at hardwood as a material that can actually do more things in terms of the joint. So that's all to look at, and that's, I suppose, pointing to some future discussion. And that's it. Thank you very much.
Afternoon, everyone. Thank you very much for the opportunity to speak at this wonderful event. We are Donaghy and Dimond architects. My name is Will Dimond. We have been practicing since the year 2000 from a small shop in Francis Street in Dublin, as Peter mentioned, and also teaching at UCD School of Architecture. I would say there's probably not a day goes by where we don't engage with thinking about timber in some form or other. In 22 years of practice, continuous and ongoing relationship really with this beautiful, versatile material, which we admire for lots of reasons. I guess its inherent characteristics, the ability of timber to respond and register in its grain the climate and the prevailing conditions, and provide microclimates, such as in this Holloway in Cornwall. Its resilience and longevity as a building material in conjunction, particularly when used with other materials, as here in Savoie in France, where the weathering of the end grain is achieved through balancing capstones. And I think there may be a couple of slides missing here, which is a pity. They were a nod to Børre in some ways. A couple of images of work of the architect Wenche Selmer, and who we have admired for a while, in terms of how she makes incredible internal environments with this material, is interested in how it spans, how furniture and linings become one kind of thing, and how the material can respond to and engage with different geometries, such as the way she planks boards around rock formations and so on. So it's we became aware, I suppose, of the role of timber in an architecture, not only as a building material, but also for its active enabling role in the design and construction processes. And this was highlighted in a number of research/exhibition projects that we were asked to take part in. In 2005, a project called Homework, Space Garden Structure, in which UCD teachers were asked to think about how they made domestic space, and the exhibition traveled to North American universities. So there were three projects we chose in very different contexts, and they were exhibited through model form and using found material reworked. So the base of the three models was weathered Turkish oak, and it had been cut by chainsaw from the shattered surfaces of a fallen tree in a client's garden. And then the superstructures are worked in oak and basswood, but I guess the timbers try to communicate inherent qualities of the landscape and the architecture within it. The three projects, one was a house for musicians in Donaghy on a coastal site, where timber was the primary structure for roofs and terraces. So there's a grass roof terrace on top of this living space which doubles as a performance space. And the boarded ceilings are used for their acoustic quality. In this project, in an inland river valley, timber is used as the roof structure, and the model was looking at making a platform off which a superstructure of insulating clay block walls and steel frame elements was raised. And in the third project, in an urban back garden site, we used red oak to represent new cast concrete walls. So only making the masonry structure using end grain for polished concrete. And then in the actual project, the enclosures and the internal linings and furniture are the timber elements. And so it's this dialogue between the two materials. And then in 2009, we were involved in an exhibition called Slow Architecture and Place, involving work of artists and architects, and it traveled on a barge through the Irish canal system. So we were exploring motivations in the working of material according to the different characteristics of materials. So classifying materials according to age, provenance, processing, embodied energy, recyclability, and so on. Our exhibit illustrated this through samples, material samples, and the drawings were burnt into plywood to reflect the humid environment on board the boat. The subject of the exhibition of our exhibit was a project for an addition to a Victorian house and a new garden building, in which the windows and doors were in oak. And the superstory was clad in staves of sweet chestnut. We were interested in this material that it could weather naturally, and by using narrow staves sourced from thinnings and finger jointing these to provide a rain screen where we could achieve uninterrupted lengths, which were a story height, and then using a single fixing at each batten. And then the narrow, I guess, dimension allowed cappings and corners to read all as a continuous assembly. And then more recently, in 2021, we made a model as part of the RHA summer exhibition, which then subsequently moved to London at the Royal Academy last year. The model was for a house that didn't get built due to changing circumstances of the client, and so the opportunity to make it in a hardwood presented itself. It's a house with 2 staircases, which rises above its woodland context to grab views of Dublin Bay. It was the outcome of a series of studies for a house with interlocking rooms in section, rotating around a hearth. And the model was made in FSC certified Oroco by a graduate of UCD, Mark Ruddy. He made the base in end grain, which he brushed to provide a raised grain for ground surfaces, interlocking planks for the walls, and end grain in herringbone format for pitch roofs. And although this as yet remains unbuilt, I suppose it's started the discussion for us about how one would build this, whether it's a vertically oriented lath construction, as in the garden room we showed you, or whether it's board-marked concrete using timber as formwork. Another small project that did get built, I guess another freestanding part of a house in a wooded garden, was for a little music room. It was for, I guess, a workspace for a musician where he could escape from the house and practice, and he was also a filmmaker. So shuttering a plinth of seashell concrete, and off that raising an expressed internally timber frame using Douglas fir board, 32 mil, Douglas fir balks as portal frames, and ceiling boards of Douglas fir plank, which had originally been intended as external cladding, but when that wasn't available, they became the roof deck. And this frame is jointed with timber dowels, which are compression fitted. And I guess the timber frame allows for easy placement of eccentric openings to grab particular views, and also gives depth for open storage in the space. And externally, it's board-on-board Douglas fir, which is stained for UV protection. And and just very quickly, an image of a reuse project, which was for a rehabilitation of a Georgian house, which had become derelict, and an upper room had burnt out. And it's also a corner site of a terrace, so there was no external space at garden level. So the opportunity to I guess recycle this room and this hearth as a roof garden, and then using timber to I suppose take the place of the internal plaster linings and provide insulation and a framing for the window back to the street. We're going to show a couple more projects in more detail now. And two projects of very different scales where timber, I suppose, was an important part in how the envelope and secondary structure of the projects was made. Marcus is going to take you through those.
So these projects, I suppose, retrospectively, at a certain stage, I don't know, I think we were drawing the projects over and realized that there was, at two different scales, a kind of reciprocal concern with how timber meets the world around it, actually. So I won't dwell on those plans, but go forward to, this is a project where we'd been working with the client in terms of their farm around their existing house in the hills above Dublin, and had worked earlier on the roof, which was where we had salvaged the turkey oak from the garden when we were renovating that roof, and then a kind of ongoing project was how to rehabilitate the tiny gate lodge, which they were going to re-inhabit over time themselves. So the avenue you see leading past the gate lodge has a row of Himalayan cedars on it. This is the small cottage. The chimney is, or the cottage is, the gate lodge is about 32 square meters, of which the chimney is about 4 square meters. So that maybe gives you an idea of the scale. And then these Himalayan cedars, which were planted in the 1850s by kind of seed collection. So it was part of this thing of arboretum and so on. So we designed a very simple, low-lying addition to the rear of the gate lodge, which was to sit behind these balsam cedars and was dug slightly into the ground as the slope went back up to the south, to slip underneath the kind of bracketed eaves of the gate lodge. So you can see where it's sitting in this concrete footing, which is dug into the glacial granite grit and boulder, up, extending up the hill. And then there was to be a timber frame set into this with a clear timber structure. So you can sort of see these two sitting beside one another and against the wall. So as we commenced the project, the client actually had the trees inspected by a tree surgeon, and the tree surgeon pretty much condemned these balsam cedars, or Himalayan cedars, around which we had designed the scheme. And also in cost saving, we'd already agreed that we would change the species of the roof structure to something cheaper that we could paint. And of course, when the trees came down, the client asked us, well, can we use these? And meanwhile, Wójcik, who was a Ukrainian builder, was implacably digging the base of this into the hillside when this was suggested. So very quickly, I guess, well, after some toing and froing, there was kind of thing of saying, well, actually turning this reflected ceiling plan into, Will made this into what was a computer-generated reflected ceiling plan, scheduled every timber, its size and length, in order that we became effectively the architects involved in the procurement of this, the milling of the timber. So these schedules. So I suppose there's a kind of thing about time here, and time and rescheduling, and what we could dry quickly enough to, with this local sawmiller called Neil Willis, and what could be sawn and dried enough, which didn't need to be particularly dry, to be used in the roof structure, whilst other timbers would be dried over a longer period in order to be used in the joinery, in the window joinery and so on. And I guess a part of the thing we're talking about in a sense of time and surprise, and we didn't anticipate using this material, but finding the people who could work with us in order to do so at a local level. So these are the planked timbers in Neil Willis's workshop. And then across the lane, across Mutton Lane from the site, this joiner, Jerry Farrell, who undertook to plane these timbers. And so in a sense, there was a kind of network of local rural economy through which, and in a sense, in a process of trust, where everyone was saying, well, this will work, but it may involve things that surprise us or we don't anticipate. And I guess, again, Wójcik, who's a Ukrainian builder, he wasn't flustered by any of this, and actually, I guess, took it on, and where I think others wouldn't have done so, in fact. So I'll keep. So in a sense, there was this thing of sorting and finding from those trees what you could use and what dimensions you could use it in and adapt to the design that we had made already. So it's a kind of reverse engineering of a material into a design that had been made. I mean, I think the other fascinating thing then becomes that this thing about timber and how it tempers a space. Because obviously the balsam cedar creates an incredible atmosphere within the house, which is not just visual, but it's about the actual seasoning of that house. So then, I suppose, parallel with all of these projects that Will has been talking about and so on, we were on a process of research which was really about using how could we use temperate hardwoods which came from a sustainable source. So we were looking at sweet chestnut from coppiced sources, and I guess reading about people like Oliver Rackham writing about woodland, and in a sense not forestry, but the tradition of woodland management as a sustainable means of yielding timber. So again, looking at small timbers and the notion that through dendrochronology and so on, that they discovered that the structure of the Bodleian Library is not made of big timbers, it's made of small squared timbers. So again, I guess you'll see laminated timber in this, but the discussion about how you use small timbers at this time, and I'll keep flicking through these because, but I suppose again within this schoolyard, this model school, which is in the context of the CIE works where there was model housing built and so on, that we were interested in how we would build in this corner where there were mature chestnut trees as well. So the section of the building is set back, the plinth at the bottom, in order that the mature chestnut, they're horse chestnut trees, survive on the site. So again, within this yard space, how that would work. And that way leave that you had to set back in order that the existing trees could endure on the site. And then looking at this thing of how to make a cantilever barn from a book that we had from North America, and then that being interpreted only as concrete in the context of actually Irish engineering. But then it became a process of how we could make an articulate way of cladding this cantilever structure with an envelope made of sweet chestnut, so that these louvers, which are laminated, would sit along the east-facing elevation looking into the horse chestnut trees and create a brise-soleil as the sun would go into the south. So one-to-one sketch drawings of detail where the fin sits to the outside and creates weathering, and then the curtain wall sits within that and is protected by it, and then there's a drainage line all the way down behind it. And each bay allowing room for these window frames to move, because there were like 10 800 millimeter wide modules per structural bay of the building. And I guess another thing just in terms of people, and Peter was talking about culture of, we say we don't have a culture of a wood culture, but in many ways we do, because we have amazing carpenters. And I think this is Eugene who was working on this project, without whom, in a way, it wouldn't, or without whom he or another person like him, you wouldn't have realized it. So these steel plates, but then how one would joint the different prefabricated frames in what's partly it is effectively a curtain wall, a timber curtain wall hung from the concrete. And then within that world, the pupils who call it the treehouse, sitting in the world of the horse chestnuts outside. Interestingly, as this, to save money, just thinking about species and so on, that the benches and so on within were ultimately made with ash. So there was a kind of, as one went through the project, again, moving and selecting in terms of what could be used appropriately according to different atmospheres within the school. And then the entrance underneath the canopy. And then this image of the kids playing within. And I suppose that thing of carpentry being a kind of coach works, or how, like coming from the thing of wagon making, and how you can make something that's almost its own vessel, sitting on a plinth made within the land, because I think that thing of how we use timber and how it joins to the land or is born on other structures is perhaps extremely important. And in a way, just a farmer's journal, and I guess when we started out in practice, we were actually researching the use of heartwood larch to clad something, and it, for various reasons, didn't get to do so, and used a tropical hardwood. And I remember when we finished, the guy, Jerry, who was the labourer on site, saying to me, oh, well, because a pretty shed-like structure, and he said, that'll be published in the Farmer's Journal. Well, it wasn't, but actually this was. And through that span of, in a way, 22 years of research and thinking about coppiced timber and how you might use it, yeah, Donal published this in the Farmer's Journal, which is probably our proudest publication so far, so thank you.
Fantastic, great. So thank you very much for Peter for inviting me here today to talk about timber research at Queen's. And slightly, I think I might have misinterpreted the brief a little bit. So I understood it as giving a brief overview of all the timber research that's happening at Queen's, which I think I failed to do anyway. But it was quite nice to still kind of try and figure out actually what kind of timber research and what research related to timber is happening in Queen's. This is not my subject matter or my area of expertise, so I will be just kind of giving you kind of highlights of different research projects and research areas that are happening in Queen's at the moment. My name is Nuala Flood, and I'm Director of the Undergraduate Programme in Architecture at Queen's. So we sit within the School of the Natural and Built Environment, and within that there are 5 or 6 disciplines, depending how you count it. But so we've got archaeology, architecture, civil engineering, planning and geography. So, you know, in theory, we kind of work together. It doesn't always happen, but sometimes there are some nice crossovers where we get to learn from each other. I'll present what I've found in terms of the timber research that's happening in Queen's at the moment. Yeah, I guess one thing to just kind of articulate is that in UK universities, there's something called the Research Excellence Framework, and that's the mechanism by which research is actually evaluated. And based on that evaluation process, the university gets a certain amount of money for their next kind of research cycle. So although we have practitioners who are also academics, who are part-time practitioners, part-time academics, they articulate the findings from their practice-based work through a text that's submitted to this Research Excellence Framework, which is, that's quite different to research in the South, which doesn't have such a formalised process of evaluating research. So it's quite interesting then, I guess, because we have this range of practitioners, architectural practitioners, who do research through practice, who find out lots of stuff, and then have to articulate actually what the findings were for this process. So I guess we all know that you find out lots of things from practice, but this process of making you question exactly what it was and then articulating what it was is quite interesting. So one of the examples of this kind of architectural research through practice is Rachel O'Grady and OGU. So Rachel and OGU have a piece in the exhibition upstairs. And part of the last REF return, they submitted their Belfast East Pavilion. And I guess they found out lots of things through this process. It was quite an experimental building and quite an experimental design process. But the articulation of the research related to timber was about how they collaborated with the joiners in Belfast, who are particularly skilled and who had this kind of quite innovative process and all of this built up knowledge. So in a way, Rachel has told me that the kind of the innovation and the findings related to this research were in how the two work together to make the design kind of evolve and come together. So it was kind of a co-design process. So there's research findings related to how you work with joiners and people and tradespeople who have like a particular kind of particularly deep kind of task knowledge of the material. and how you bring their tacit knowledge into the realisation of the building. I think it's particularly relevant to timber, which has so many variables in terms of strength, moisture content, and material properties and behaviours. I guess quite excitingly, they have another installation that is currently being realised on Adelaide Street in Belfast city centre, and this kind of builds on that earlier research. It's a kind of a public realm improvement project, and there are various timber pavilions within it. So it's part of this pedestrianisation of Belfast, that kind of bigger kind of drive to pedestrianise a lot of the city centre. So part of this project is pedestrianising quite a bit of the street, 2 lanes of traffic, I think. And there's this series of pavilions that are made with Irish larch, and they are fully able to be disassembled after the project is kind of comes to the end of its life. So it's quite interesting. I assume there's going to be, in the next ref return, there'll be lots of research contributions that will answer things about kind of circular economy, reuse, design for deconstruction, and that kind of thing. In earlier ref returns, the previous ref return, this Slieve Bawn Oak house by Clancy Moore Architects was submitted, and it answered certain kind of research questions at the time, to the best of my knowledge, about timber frame construction, about how it can happen in Ireland, how you can work with an Irish timber frame manufacturer. And it was also about things like kind of building really close to trees and foundation issues. So the next thing I found in my own research into how timber research happens at Queen's is the archaeology department does a lot of dendrochronology, which is particularly in old buildings across Ireland, both north and south. And this had started actually in the 1970s, to my surprise. There was Professor Mike Bailey at Queen's, and so they do a lot of the old structures in Ireland. They've done the dating of the timbers in Rathfarnham Castle, in Angel Street, and here we have Finnebrogue House in County Down. So essentially what they do is they take a core sample from the timbers, and then they count the tree rings. And they can actually date things really accurately to ±9 years, apparently. And here we have images of them dating or taking samples from the stairs in Emil Castle, which the timber there was felled in 1624. So then we also have a heavy structures lab, which I have seen many times while I've been in the building in Queen's, but never really questioned actually what it was they were testing then there. So this is quite interesting. They do a lot of research related to the strength of timber and the moisture content of timber, and looking at how you can use different elements to strengthen timber, and how that will kind of change the structural properties of that timber. So here we have the strengthening of timber beam with post-tension basalt fibre reinforced polymer rods. So essentially they make up a sample, and then they stress test it. So that is Professor Sue Taylor does a lot of work there. So it's not just in beams, sometimes it's in sections as well. And then we have a lot of research related to CLT and the performance of CLT and moisture content of different CLT samples. And this is Dr. Danny McPolin, and more recently he's done work related to multi-story structures using CLT. And quite interestingly, they use another mechanism called the knowledge transfer partnership, where they do a lot of their research with industry. And what they'll do is they'll get to kind of recruit somebody who will work with the company, but also with Queen's at the same time. And as an academic, he will kind of base himself in the company for a little while as well. And then that whole kind of mechanism of getting research done is funded by central government. It's another kind of, another mechanism that I'm not aware of that happens in the South. And then I guess the kind of crossover between the disciplines happens, I think, mostly through teaching. So for instance, here in this project, Timber, which was led by Professor Michael McGarry and Susie Brown. So what they did was they worked with Dr. Danny Poland to look at how you could do adaptive reuse of the Sonic Arts Centre at Queen's with CLT. So that was a studio project that brought in a lot of the findings of the research from the CLT structural analysis into the studio, and then working with the engineering team to see actually how you could adapt this building using CLT. And then another kind of body of research was carried out, I guess, in 2019 in this project called Public CoLab that I run. And the idea with this project is that we work with different external partners every year and kind of respond to what they need done for the improvement of the public realm in Northern Ireland. So this year we worked with our Future Foil, who were a charity type organisation, who were looking at reinvigorating the riverfront around Derry because it's particularly problematic. It's not well used. It's underappreciated. So the students designed a series of pavilions using So they designed a series of pavilions in model form and kind of modeling at 1:10 and using the laser cut models as a representation of how this would eventually be built using plywood. So the models, I guess, are a representation of how it should be realized. So I guess the research question around timber was how much can a model represent what's actually going to be built on site. So we worked with that organisation to build a lot of these models in the end, and about 6 of them were realised, temporary structures along the foil. And I guess the research finding is that the models didn't quite stand up when they needed to be built on site. But it was quite a nice process, really nice for the students to learn kind of how they might realise something and the kind of the limits to modelling. So that's just a really brief overview of the kinds of timber-related research that's happening at the School of the Natural and Built Environment at Queen's. You can, if you want to know more about any of these, you can. All of this research is in research papers on the portals related to each of the academics. Okay, thank you very much.
Hello. Okay. Oh, I must say I'm very intimidated being a third-year bachelor student standing up talking among all these experienced architects, but sure. If any of you are unfamiliar with CCE, it's a joint partnership between UCC and CIT established in 2006, and I suppose you can think of it as UCC providing the more design mentality and way of designing behind it, and CIT is the architectural technology side. So it's kind of a hybrid of technology and design at the same time. Oh, fun. Okay. So I suppose the main kind of sector of research in staff would be this project here, which is natural energy efficiency and sustainability, which is a mouthful, so I'm just going to say NEES from now on. It's kind of developed to try and identify best products, best principles, and services that promote sustainable architecture through, let's say, timber frame, cellulose insulation, hempcrete, all of these kind of materials. And they compiled a list to try and promote these services as best they could. So there's 8 partners, the head of which is our director, Professor Kevin McCartney, and it was established in CCAE through kind of mutual staff interest in housing developments which used all of these materials, and they decided to apply them to a much larger context, which was in the UK and Ireland, and it's spread out through regions in Sweden, Greenland, and any country you can think of with a really harsh climate. It's funded through the Northern Peripheral Program, I think it's called, NPP, and it's basically a program established to help regions in the northern peripheral of Europe to develop kind of socially, economically, environmentally, and they specifically seek out projects that are full of innovation and sustainability towards local and natural resources. So it was perfect. Yeah, so the goals, am I supposed to run through this? I did run through this. I'll just skip it. Yeah, perfect. Okay, so to evaluate all of these projects, they set up 6 pilot projects, and of course these needed to be tested to see how energy efficient these systems actually were. To do this, they had to test these projects against conventional building practices, which in Ireland, I believe, was just concrete, concrete, concrete. To do this, they looked at how energy efficient a resource would be compared to what would usually be used in conventional architecture. Along with that, the environment and the health, so how the building related to its environment, how the impact of what you were building would react or how it would transform in a couple of years, and also looking at health factors, so not just of the user but of the people actually building, how certain materials like certain types of insulation you can only install using protective gear because it's so irritating to skin. Certain products might have harmful gases like formaldehyde, which is detrimental towards lungs, skin, and eyes if you're exposed to it over a longer period. Along with that, the sustainability, of course. Now, that doesn't necessarily refer to kind of reusing and recycling, but it also refers to how it would sustain itself if the demand were to increase in a number of years, if it was to be applied on a much larger scale. Yeah, okay, so this is one of the projects that I'm kind of most interested in personally, and it's one of 6 pilot projects for the NEES program. It's Parnell Cottage in County Cork in Cloyne. If anybody knows where Cloyne actually is, please let me know, because I have no idea. It is a cottage that was one of 40,000 built about 100 years ago in the space of 5 years. So as you can imagine, for some reason Ireland didn't insulate its buildings back then. So the living conditions in here, not so good. Very moldy, very cold, very miserable. And it's owned by a female client who has a specific sort of allergic reaction to many products like laundry detergent or washing up liquid. So for her, it was very, very important to create a building that was completely natural, that absorbed as many toxins as possible, and that was healthy, in other words. So this project was actually scheduled for a demolition when it came into a brief, and Kevin Gartland Architects suggested instead that they try to renovate it, and if needed, put on an extra extension that would help the living conditions, but also create a much more healthier environment. So as you can see from this photo here, the extensions were put on quite awkwardly. They didn't do much, and given that this house was about 2 or 3 bedrooms, I think, fairly small, all it did was actually just worsen it because it blocked all the sunlight and didn't really make any usable outdoor space. So instead, they decided to demolish all of those walls that weren't in the original construction and recreate it. So this project was to apply 5 best principles identified by NEES, which was, I'm going to forget them, but I'm not going to turn around, timber frames, which would be put onto the extension to kind of give it a much lighter and more natural feeling. I'm going to look, I can't see that. I forgot my glasses. Adding on a green sedum roof, which acts kind of more as a way to tie it in with the environment, but also as an insulating factor and also just a natural sort of element add onto the building. Triple glazed wooden windows, which actually caused a bit of a problem when you talk about the BER rating of the house, and I'll talk about that later. Then, oh yeah, cellulose insulation. If you're unfamiliar with it, it's a completely recyclable and reusable paper insulation with really high properties, so it's amazing. And hempcrete external insulation, which also caused a bit of a problem with the BER rating. Okay, so what was actually done? So as I mentioned, the client with the allergic reactions, it was really important for her to have a very healthy environment. So to kind of line the building with, well, in terms of the extension, they used smart ply, which is a type of plywood that doesn't have formaldehyde in it. And it's a gas that's actually used to create many kind of chipboard, OSB board, that kind of thing, because you need it to bind it. So that was applied along with cellulose insulation and a very light timber frame. Now what that actually did in the end was it decreased the mass of the entire building by about 64%, and the extension itself compared to conventional use would have been 78%. So that's a lot of saving in money to translate it in simpler terms. And then Yeah, cedar shingle was applied to the outside. This was kind of to give the building, again, the natural feeling. It was also very low, it was locally available on the market time, very cheap, and what it did was allow the building to age gracefully and naturally with the building over time. So think of it as going from a warm brown color to a very light silver gray, kind of what's going to happen to my hair in a few years if I stay in college. Okay, don't get too caught up with those numbers there, just look at the BER rating. So as I said, the conditions of the house before this weren't great. A G rating basically stands for get out. D1 is not great either. Now, I've lived in Ireland for about 17 years. Any house I've lived in is actually very cold. I don't like it. But D1 is not good. The reasons for that being was that one, hempcrete, the material used to clad the outside of the walls on the cottage, wasn't actually that well recorded, and I guess people who were kind of analyzing the building didn't really realize how insulative this material actually was, so it was just down to maths in that case. The other thing with the triple glazed windows, so there was a very high ratio of them to floor area, meaning that basically people thought that maybe it was kind of overheating the house or it wasn't in the right orientation, even though it actually was. But also the material that was used was Iroko wood, I think I pronounced it correctly. It's a wood, it's a tropical hardwood grown in Africa, basically saying that it has a very high embodied energy. What that report didn't take into account was that they were actually available 20 kilometers down the road from Munster Joinery, but that's a different thing. Yeah, so I guess then the conclusions of these. This project began in 2010 and it ended in 2014, so it was about 3-4 year project. And overall, the partners were very happy with how the project went. They said that they were very surprised at the amount of support offered from individual practices, but kind of negatively surprised with the amount or lack of official support from kind of the regulatory standpoint of things. But the best thing, I suppose, from this was that NEES actually became the concept for CCAE, and it later evolved into the teaching that was offered to students. I'm surprised that image showed up. It caused so much problems this morning. So I suppose the kind of more interesting project from my standpoint was this one, which was the Maker project of first year, introduced about 2 years ago. So as Børre was explaining earlier about kind of triangulation and this, whatever. It's based off of Buckminster Fuller's projects on geodesic domes, and if anybody isn't familiar with him, he's a man who actually refused to identify as an architect, and he spent a lot of his time working in the Navy, working with ships, and he was very concerned with the weight of a building and being able to achieve the most possible with the least amount of materials. A very good standpoint, to be honest. So in first year, I like to think of it as not so much architecture, but as a year of just exercises, trying to break out of like a secondary school direct mentality of learning. Instead, you have to use your own head, you have to think creatively and innovatively to try and solve problems that you yourself are actually creating. Ooh, that's a lot of writing. Okay, so this project basically asked the students to think creatively. So, I'm going to read from here, okay, so they were given a kit of parts, which think of it as maybe 50 wooden skewers and a bit of plastic to make joints. And out of this, they would need to make specific shapes that were kind of triangle shaped and try and make a spatial configuration that worked efficiently but also used the least amount of materials and as little waste as possible, which was a very key point on this. Diversity. So this was a 2-week project. So the first week they would have to play around with these configurations. The second week they'd have to make a 1-to-1 prototype. And by that I mean something maybe my height, maybe a bit like smaller. But they had to think about scalability. So is this project still feasible? Is it still a good solution when it is applied to a much larger scale? And as you can imagine, in first year, when you don't really know what you're actually doing, you spend the first 2 weeks drawing in the city. This was a very big ask, but it was brilliant because now they have a much better grasp on how to approach these kind of topics. So, unsurprisingly, they started to come up with very similar configurations to those of the geodesic domes from Buckminster Fuller's project. And in the end, unlike most college projects, they kind of had to consider every single aspect of it. So my favorite thing about being able to do a project in first year was that I could ignore a lot of parts of it. I didn't need to think into detail about certain things, even though I was in a technical college and still am. But you could ignore the joints, whereas here they had to be very careful and to design them in a way that used as little material as possible because they themselves had to make them. Now, some of the students did actually end up using metal in the joints, which is fine, but that just meant that they had to learn how to weld. And this is a study from a current second year when he was in first year, Egan Murphy. So as you can see, already he's applying the idea of scalability and trying to determine what spatial configuration you can make from triangulation by looking at what kind of scales this project would be feasible at. So kind of like what Fuller did with his projects, there's a park and then there's kind of the hut for animals, or it can be used as a shelter for humans. So overall, I think a really brilliant project. And another thing I suppose in third year now, since Professor McCartney was the kind of founding partner of NEES, he introduced a module that he's been teaching for the last, well before I was in the school anyway, called environmental design. So it's not necessarily based on timber, but it is kind of helping architecture students can determine how energy efficient their building is in the preliminary stages by looking at things like the LT method, how much embodied energy is in a material, concrete, timber, steel, anything like that. And along with that, if any of you have heard of the 5-point star, that's also analyzing it towards the very end. So yeah, very short presentation, but that is it. Oh yeah, 10 secondary structures they're actually all over our building now. They're not even hanging anymore, they're just in the corners. But this is a direct development from the Maker project in first year that they actually made later in the year. And this is kind of a structure that uses tension cables to try and make it stable without having the pieces connected to each other. So it's a very interesting study. And yeah, that is it. Thank you.
Yeah. So my name is Marcin, Wójcik, and I'm a lecturer in Dublin School of Architecture at TU Dublin. So TU Dublin was established in 2019 by the amalgamation of Dublin Institute of Technology in Blanchardstown, and Institute of Technology Tala. Dublin School of Architecture at TU Dublin offers a number of programs ranging from level 6 to level 10. In this presentation, I want to outline wood-related academic activities within these programs, as well as individual staff research. So this is a new program only introduced in 2021, which is called Sustainable Timber Technology Program. Program is one of its kind in the country to produce graduates who know the complete supply chain of the forestry sector, directly from logs to engineered wood products and their marketing. In short, the idea is to produce graduates who are the wood material experts. You can visit the QR code and see more information about the program there. This program is an immersive 4-year full-time program with a mix of theoretical and skills-based modules. Cross-sectional skills such as critical thinking, creativity, management, collaboration, and professionalism support the central focus of wood science, timber skills, and production management. The program has strong links with industry. Field trips, guest lectures supplement the academic content, and work placement takes place in the 3rd year. As you can see here, also there is a research component in the final semesters. So we believe our graduates will be industry-ready timber technologists. They will be generalists at the center of the timber industry, creating timber products, managing businesses, driving innovation, supporting specification, adding value, and maintaining quality. So the Dublin School of Architecture rigorously follows the climate action agenda since a couple of years. Many teaching modules in the school are centered on wood. 3rd-year architectural technology students focus on wood as building material by studying exemplar timber buildings, drawing, 3D sketching, and modeling structural systems, and also by design investigation, structural analysis, beam modeling, producing GA drawings, and detail studies. Over the last 10 years, architectural technology students have engaged in an intensive research assignment in their final year, which is their 4th year of studies. The output from these studies is seen as a genuine contribution to evidence-based research within the building industry. The final project in 4th year provides an opportunity for detailed analysis of current emerging issues and that that arise in the life cycle of buildings. More than 275 of these studies have been carried out so far, with topics ranging from energy efficiency, retrofitting, building pathology, to material science, procurement, and even novel building products. Timber research has formed a backbone to the chosen topics and themes over those years. The students publish their work each year via the empirical journal, you can see here. And furthermore, each year, Architecture Ireland magazine has committed to featuring a selection of the research studies undertaken by the students. In the BArch program, fourth-year architecture students work on a county-wide level in developing architectural projects with critical position on climate action. In the academic years 2029-20 and 2020-21, this took the form of group research, analysis, and strategies for areas of interest within County Carroll. Split between 2 semesters, students were tasked with developing their own briefs based on their ecological stances and leanings. The driving force behind many of the approaches were taken from the UN Sustainable Development Goals, or SDGs in short. Part of the briefing requirement was to explore the use of wood in construction. Also in the BArch program, wood was the primary material in the elective design studio, led by myself together with my colleague Jim Roach, where students worked with real clients to design and construct small-scale architectural projects, such as a new market stall prototype for Moore Street in 2019 on the left, and pavilion for St. Mary's Secondary School in Glasnevin from 2018. Designed and built together in conjunction with both with the TY students from the school and also German carpenters who, from Biberach, who used to be our partners at this time. Yeah, at the master's level, to architecture, together with my collaborators, I periodically run workshops focused on computational design and digital fabrication. Digital timber workshop that you can see here on the slides was based on using Rhino plugin Grasshopper, CNC milling, and the HoloLens Microsoft technology to design, manufacture, and assemble discrete timber structures. And this type of workshops feed into master's thesis, student thesis, such as this one, reviewing the ideas of structuralism by the lens of computational design and modern modular timber technology. Yeah, so Dr. Samir Mehra, who is with us here, is a wood scientist employed last year by Dublin School of Architecture to expand the school's timber research capacity. Samir has quite a unique and international background in forestry, wood science, and timber engineering. In 2021, he was awarded a PhD in engineering from the National University of Ireland in Galway. As part of his PhD, he worked on an Interreg Northwest Europe research project titled Towards Adhesive-Free Timber Buildings. His research interests are largely directed towards applied research in the field of forestry, wood science, and timber engineering. Samir is particularly interested in wood modification techniques, timber material characterization, designing mass timber products, development of non-metallic and adhesive-free timber connections, and bio-based adhesive systems for wood products. These pictures show some of the non-metallic and adhesive-free engineered products and connection systems produced by Dr. Mehra during his PhD research at NUI. This research is aimed to minimize the use of synthetic adhesives and metallic connectors in timber buildings by using engineered wood products with high sustainability and recyclability potential during the production phase, as well as in the end of life. In these beam column and frame connection systems, Samir replaced synthetic adhesives with metal connectors with the specialized wood connectors produced using densified wood. It runs. This slide shows the production process of densified wood. A densified or compressed wood is a modified form of wood with the strength and stiffness properties. In wood modification, wood is thermomechanically compressed at a temperature of about 130 degrees centigrade and pressure around 2 tons to improve its structural and mechanical properties. These graphs show a comparison between mechanical properties of compressed and uncompressed wood. The density, bending, stiffness, and flexural strength of densified wood are almost 2 to 2.5 times higher than the uncompressed wood. The superior quality compressed wood is converted into small dowels to produce the connectors, and then these connectors are used in engineered wood products and connection systems. Compressed wood has interesting spring-back behavior, which is responsible for continuous swelling in compressed wood as time passes. This ensures connections do not loosen over time and keep its structural integrity of the elements during the service life. Using Samir's research findings, a demonstration structure was built in Liverpool just before lockdown. This structure is a lab space at the Ness Botanical Gardens in Liverpool. It is installed with hydrothermal sensors to evaluate the performance of the structure. Yeah, so my own PhD doctoral research was carried out at the Oslo School of Architecture in Norway, where I actually met Børre, who was institute leader, head of Institute of Architecture at the time when I arrived, and I don't have to probably stress it that he was a huge influence on my project, and his work was a huge inspiration for my own research and the thesis that I defended in 2020. The thesis focuses on the relationship between material-centered design, digital technologies, and environmentally responsible practice with respect to wood construction. It argues that computational design methods and digital manufacturing have the capacity to reframe wood construction, open new opportunities for design, and lead to more sustainable practices. So I argue that while traditionally materials were concerned either in technical or aesthetic terms, sustainability caused a shift in architectural theory since the 2000s, 2010s. Oh, sorry. My thesis corresponds with the new perspective on building materials that began to emerge. These new perspectives are such as emancipating material as an outright counterpart to form, biographies of materials, or contextualizing materials vis-a-vis modern technologies. My thesis was derived from 3 experimental projects with wood that were carried out in order to investigate an alternative method of wood design, one that can be characterized as material-centered. These experiments guide the theoretical investigation. The experiments were not developed into full-blown design solutions. The thesis is not technical but theoretical. It deals with metaphysical rather than practical questions and aspects of material and design. The departure point for the experiments focused on the processes that seek environmentally responsible production methods of architectural components. These methods investigate how to access and harness phenomena already existing in wood through computational design and digital manufacturing techniques. Keep on pressing this. The aim of the back-to-back experiment was to demonstrate an alternative method of connecting solid timber components by harnessing shrinkage in green wood as it dried. It also tested the viability of CNC machining for producing permanent connections based on this shrinkage. The swelling vault experiment seeks solutions for achieving double curvature in wood or double curved wooden shells by reframing the problem rather than developing the existing wood bending techniques further. So it took inspiration from moisture-induced parquet buckling and tested how the buckled shapes had been affected by various block patterns and how the emergent shapes could be predicted by digital simulations. And the White Timbers project investigates the implications of designing with naturally grown shapes of wood, in particular which design and fabrication techniques are required. The motivation was to challenge existing design logic. In mainstream design practice, materials are selected after the design of architectural form. This experiment used the opposite logic, where the natural shapes of wood dictated the type and form of the designed elements. The ambition of the experiment was to explore the possibility of using this material in cellular arrangements. The project employed 3D scanning and robotic fabrication. So these three experiments in my work led to a dissertation that was a monograph based on several papers published based on these experiments and the theoretical perspectives onto these experiments. Yeah, so this, in short, in 10 minutes, is my a quick outline of what's happening in TU Dublin at present.
Well, one thing is clear. I think we need to continue this discussion. There's so much diversity out there, and I must say also for a third-year student to be able to talk amongst practitioners and theoreticians is quite extraordinary. I thought you were very fluid in dealing with very complex. That's okay, I will be. Now, I know there's a rugby match on, and I've been told by Sally that she needs to get home as soon as possible, but I'm going to try and be as quick as I can. I might leave for a discussion on the papers that the university staff presented to the later point, and we might have a more full questions and answers session if that's possible afterwards. So I'd like to introduce Merritt and Karen Bucholz McEvoy. They're a practice that were established in 1996. I was incorrect with 1995. Merritt and Karen have been, again, I would say, a formative practice to many young architects at the time when they set out and won many competitions for civic buildings, particularly Fingal County Council, Limerick County Council, Leinster Pavilion. There's one particular exhibition that remains very much in my mind when I think of Merritt and Karen's work, which was a piece that they made for the Peter Rice exhibition in Phoenix Park, a most beautiful joint, which was a study of asymmetrical loads and jointing in relation to what they were trying to do in the Leinster timber pavilions at the entrance to Leinster House. Merritt and Karen are currently working on the Toronto and Region Conservation Authority, which is a waterworks project, and it's an administrative building that they're building entirely from timber, and I'm hoping they might introduce that to us this afternoon. So without further ado, I'd like to introduce Merritt and Karen to you. Thank you very much.
Thank you very much, Peter, and thanks for inviting us today. It's for a very timely discussion, and a double honour to be doing it in this building. It's a beautiful building, of course. So we'll be as quick as we can because I understand everybody wants to get home. So we're just going to talk quickly about some of our earlier buildings, and then we will talk a bit about our recent work in progress in Canada. Starting, I suppose, just I won't bore people too much with the earlier projects, but I suppose I like to come back to this image in particular, and from Fingal, with the spar, the oak spar as we call it, and the Himalayan cedar behind it. And that's project. I suppose there was an already constrained site. There was a crescent of wonderful oak trees, and a Himalayan cedar, which it was assumed at the time would be removed to put the building on it, but we wanted to keep them, and they suppose they informed the configuration of the building, but they also offered us a canopy to which to approach the building and kind of attenuate that entrance sequence from the main street into the building. But I suppose it was the start of our journey with timber. In the earlier projects, we tended to use them more, looking back now, more as discrete elements, often within the supporting the environmental strategy of the building. but it's just, I like this image because it just, I suppose the aspiration to be working in a positive collaboration with nature and natural systems on all levels was always there from the beginning. Earlier on, it was more about reducing the operational carbon and all the levels of that, and natural ventilation and daylighting and everything. And that's evolved into more a deeper knowledge and use of timber in the projects. So I suppose, so how do I use this thing? Where do I point at here? Okay, sorry. So this was Limerick County Council, where we were, I suppose, we always tend to think of and talk about our buildings as breathing organisms. So that's what I mean about the environmental strategy. We tend to talk about the volumes and the skin of the buildings in that sense. So a lot of them have atria because they're really working as lungs for the building and helping the building to breathe. And then the breathing skins are always articulated in a way that's an immediate response to the particular microclimates. Working with our engineers all the time in articulating those skins to make that system of ventilation and work with the environment to create a comfortable environment for the people using and working in buildings. So here we had the challenge of a very long southwesterly facing atrium wall. So we were using timber here as a structural element with Scots pine trusses that at the time, it's not obvious, we were looking at boat building and Quirks, and we were also looking at the calibration of the actual truss, and all of those pieces along the southwest orientation were calibrated in order to respond to the path of the sun and give us the shading we needed. And also inside, then they act as a kind of a light reflector down into that space. And then this another project in Westmeath, where the challenge was quite a 4-metre drop across the site, and some old buildings and the remains of an English jail, which again were going to be knocked, but we wanted to try and incorporate them into a kind of an inside-outside public space that might be a gathering space between a few different elements, the library and the civic offices. And so we were using timber for its flexibility and its versatility in terms of getting those kind of shapes, and also trying to, in the facades there in the bottom left, where we had a double facade here in this context, which was giving us a breathing facade, but also an acoustic buffer to the railway line. And then in the library, creating deep fins that would also give us shading. And a project for SAP, where call center were very intense 24-hour working. The SAP at the time were looking for calming, kind of a breakout space for the employees. So we were using timber in this context in the atrium, which is kind of this buffer space, which also acts as a breakout space, with that reciprocal roof structure with LVL, also offering us some shading, and that those breakout spaces in the interstitial spaces that are part of the environmental strategy, which offers these other new spatial typologies of those in-between spaces that can be then used in different ways. At the time, it was an emerging thing. People were looking for those interactive spaces where people could do different types of, get away from their desk and do different types of work. And then at the same time, we were working on other smaller scale projects. This is Quirke in Marion Square, an IAF project with Crash Detector, where we were working with a boat builder in Galway. So we learned a lot about the raw inherent characteristics of each of the pieces of wood, the oak, the strength of the oak being used in the bottom of those pieces. It's basically it's like a flower, petals open and closes to make it when it was in use, to be opened up and then closed down in the evenings, and with, as I say, oak for the strong base, cedar for the curved pieces, and then we had, gosh, now I'm forgetting, ash and sail cloth over the whole so very much inspired by what we were learning from boat building at the time. And then this was the Leinster pavilions in front of Leinster House, were very sensitive, beautiful, magnificent trees. We were trying to put something very lightly in between. Obviously, had to be very careful of the roots of the trees and make something as light as possible in a very short time as well, when the TDs were off on their break. So that was another. So it was like a little prefabricated piece of furniture is how we looked on it. And so we were looking very much at the jointing and how we could concentrate everything in that horizontal layer and maintain that invisibility across, so that we weren't interfering with the trees or the view into Leinster House. So we were using large glulam and oak for the Irish oak for the furniture pieces, and then a larger scale in Elm Park, where we've always been using timber, I suppose, just as a very versatile material that can be used in that filigree of that layered up skin, breathing skin, which changes, as you can see it particularly here, I suppose, as it turns its face to the sun or to the wind. It has different needs of shading and ventilation, and so we were using it in different ways there, and also blurring the boundaries between the inside and outside in that space with these large Scots pine diamond trusses reaching down into the large garden. And this was our first opportunity with Donaghy Rathdown, I suppose, to use timber as the primary structure of the building. So this is all mass timber structure, 3 stories. It's a workspace for Donaghy County Council's. It's a depot. We were again very concerned about trying to make it the breathing building and that connection to the landscape beyond being something very immediate, and the ability for people to, move from their desk and open the windows and have that control over their environment. As you can see, it slice through the facade there, with large sliding panels which can be totally opened in the summer. It's a south-facing facade, but it also has the winds coming over the Dublin Mountains towards, so we needed to create that kind of screen as well to it. So so we were using CLT for the first time, I suppose, pine CLT, and large glulam columns and beams. And then for Dunleary as well, across the way on the Sam Beckett Civic Campus, there were different environmental challenges in terms of making the environmental strategy work. So we were challenged we were looking for more thermal mass, which the timber wasn't giving us. So we have kind of a strange situation where we have timber holding up concrete, big, massive, muscular spruce columns and beams holding up precast concrete. And then this folded, pleated facade where we're trying to get, again, the openings is all environmentally modeled to inform where those openings are, and that depth that we were trying to get in the facade as well. You can see that's the same project. One of the kind of the pop-ups in the roof that are like air and air wind catchers, but also light catchers, bringing light down into the center of the building. And then on the left, that's the facade where we were using this kind of shingled, kind of harking back to the stave churches, and Børre knows all about that diamond-shaped shingle, which kind of directs the water flow and hence the weathering, I suppose, so that you're kind of controlling that sense of how the weathering is going to manifest in a number of years, which is always what clients are worried about, the inconsistency of that, which, I don't know, it's an organic material. Why that anyway. So this is not far from here, across the way in Meath County Council's office, where we were inserting into an existing building this kind of lantern, where we were trying to created better conditions within a large space, acoustically, from an acoustic point of view and from a light point of view. So we were also looking at the timber in terms of what could we do to minimize or eliminate any metal connections. So it's all in timber, cedar frame, and birch ply, and all dowelled with cedar dowels as well. So also as reference to the wonderful joinery we do have in this country. So it's very much a manifestation of that. So this then is brings us to a project in Canada, where we're working with this very interesting client. They are a planning authority, but they've grown out of the situation in Toronto, where it's developed over the years on the underlying bed of these watersheds and ravines which drain down into the Lake Ontario. They're where the glaciers retreated, and so you see this carved out into the topography of Toronto. The organization itself, I mean, yes, it's an administrative authority, but actually it's made up of very interesting groups of ecologists, scientists, hydrologists. I mean, incredibly engaged group of people with a sustainable agenda really as their mission, because a lot of these ravines over the years had been concreted over or filled in, and hence there's been flooding issues, and so they were established on the basis of that, and so they control any development within the ravines. Now the ravines unfortunately had become dark places in Toronto, I suppose, because they were crime-ridden and nobody was wanting to go down there, so there was a very strong disconnect we found between the large, very large road infrastructure around Toronto and then these ravines. These are some of the people who work there. You know, they're out doing research on the land in their boots a lot of the time. So they're in and out of this building, and they're collecting insects in the ravines, and they know the ravine, all the layers of the ecosystems of the ravine is kind of in their DNA, and they're very conscious about preserving and supporting that. So this is the site, which is located on the edge of the ravine. So there was an aspiration within TRCA as this development authority, to create an exemplar building that would be a way to show people to show others how one could develop in this transition zone along the ravine's edge, and respecting all the natural systems of which it's part. So right beside it, we have these large roads and this large hexagonal structure of the Tennis Canada, and acres of parking. So I suppose, just in terms of their brief to us and their agenda, it was, I suppose, was a few prongs to it. Both the workplace, they wanted to have a much more interactive workplace between all of these very interesting groups of people, so that when they're looking at new planning applications, they could have these intense collaborative events, and they were also very conscious about creating a healthy workplace. So they did have all of these certification, WELL certification and LEED and Toronto Green Standard, which they wanted to target. I suppose we've always been conscious of these, but I suppose the most positive use on this project has been the way that they've kept the design. The design team were very much supportive of all of the sustainability aims, but right through to the site, where we discovered actually that the timber, although there's plenty of resources in Canada, Western Canada is much further ahead in terms of the more recent use of timber than Eastern Canada and Toronto, where the experience is still very much in steel and concrete. So it's been, Merritt will talk more about that in a bit. So this is what the ravines are like, these amazing trees. And so the challenge was how we could set something within this context and not impact it in a too negative a way. There was a lot of talk about the biodiversity that was existing and how that could be, in general, this is what the TRCA was working on, how they can support the biodiversity and these wildlife corridors through the ravines. So this is what the ravines look like, these wonderful old sugar maple shacks where they harvest from the maple trees, the maple syrup. So they have a wonderful tradition of this. So this is the context. You'll see contemporary Toronto in a few minutes, which is quite different. So it's a strange juxtaposition of the old. This is actually owned by the TRCA across the way. It's called the Pioneer Village. It's Black Creek is the creek, the ravine we're working within. And so they have these wonderful old barns that have been there for quite a while, and as we all know, they've been replaced, over the generations by different generations of people, and different components changed, but they still are wonderful, wonderful structures. Some of the interiors of those. So this is the kind of context. So this was, I suppose, one of the first just images we made, but this aspiration to create this democratic, I suppose, workspace that they were looking for, really embedded in the experience of the ravine. So really, that the presence of the ravine would be omnipresent in the midst of these trees. They have, as I say, quite a complex organisation. They had a project where it was a stacked rectangular building of 8 stories that would have very much reinforced the disconnect between all of the departments. So there was an aspiration to try and create a lower, flatter organisation, and that was one of our challenges in terms of organising the building, and the sense of how we might craft, the form of the building around the workspace we were trying to achieve, and with that constant presence of the ravine beyond. This is again an earlier one where we were looking at that layered skin to the right, in terms of that climate mediator between the inside and the outside. And of course, we have quite a different climate here, much more extremes. So from the beginning, we were trying to extend the amount of time that it could be naturally ventilated, so that in the shoulder seasons. So that was what a lot of our work was, in creating the skins of the building and trying to optimize as much as we could in harnessing the sun's energy on the south. And then to the left, you'll see what's called, we've brought in water walls in that environmental strategy, which we'll explain in a minute. So this was some earlier diagrams looking at the sun and the wind path and the kind of microclimate that's created in the ravine. And then this aspiration to try and stitch back a bit into the city and to heal that relationship between that has been so disconnected between the ravine and the city, and for the building and the site to be more of an invitation into the ravine and an invitation into a ravine that might then respond by stepping down into the ravine. So this was one of our earlier models, and this is a bit of closer in where you can see the shape of it emerging as this kind of a fan shape, I suppose, with the wider end of the fan towards the larger roads as the invitation, the end that people are coming in from the city, and then bringing people through and creating this kind of concentrated focus around. There was a beautiful copse of 4 or 5 sugar maple trees. So that's where we've organised the activity of the building, the more the social and the collective activity inside the building. So these are again some earlier models about how we could open up the form of it and aerate it with light and air, and create that movement towards the ravine around those trees. And the trees are. The amount of, it was a fascinating process actually at a practical level to go through a planning application process there, working with our partners ZAS in Toronto. It was quite eye-opening actually compared to how development is looked on here, where in a planning application you're always looking from the impact on anything from the soil up, let's say, and the built heritage. There, the concentration from the beginning was all about the layers underneath, the nourishing layers, let's say, and how we were going to be impacting those, and the trees. The trees, there was talk about the distinctions between all the different trees, urban woodland versus ravine trees. There was so many discussions about the exact detail of the drip line of the trees, the canopy of the trees, and all of these things were defining the constraints on the footprint on the site that we were to work with. And then, of course, the water systems and how we could work with them and improve the drainage in a more sustainable way with the landscape down into the ravine. And these were just starting to look at how we might open up that section. And also along the south side, I mentioned try to create this kind of a preheat space, south-facing, and thickening that edge, that pleated edge to the southeast. North is to the top of the sheet in most of these. That pleated edge down towards the ravine around those sugar maple, and then looking at these. So we brought in these elements of solar chimneys to help with ventilating the building, and in concert with water walls, which also mediate the temperature of the building. And this is how it sits on the site then, coming in, as I said, from the left, from the west side, coming into the heart of the building, with all of the public areas and the exhibition areas and civic areas and conference rooms in the heart of it, and opening out towards the ravine end with the canteen area and the social terrace out at that end. And it's just showing how it was organized then, the workspaces on the upper levels along the kind of spine of the fan shape, I suppose, and then on the bridging pieces in between towards the west, the longer ends, they were the meeting rooms and the quieter end of the buildings for the different departments and different groups, and then towards the ravine end, the more open interactive spaces, and also locating a main stair as the main focal point in the middle of the building, which invites people up and up through the different levels along that pleated corner overlooking the ravine, which then also became, when we were working with the structural strategy, became the main bracing kind of element. So we're kind of creating this weave that's concentrating a lot of the energies along that staircase and aligned well with the structural strategy. So there we were looking to, within the rigor then of timber, and looking to see how we could organize the structural strategy with timber cores. So we managed to maintain the timber in the cores, and then the bracing down on the bottom right, overlooking the ravine, and those water walls I mentioned, those blue rectangles punctuating the ends of the atria. And this was one of the earlier images of what that might start to look like, with the roof lights bringing light down into the heart of it, and the water walls beyond there in the distance. And constantly, and then it's the top right there is just an image of that staircase coming up along the edge of the ravine, so people are always constantly in dialogue with the ravine. And then looking at this kind of landscape of workspaces they were looking to achieve, which were apart from the workstations in the open plan areas, they wanted these areas where they could have these, what they call triage events, when they want all of the disciplines coming together to look at a planning application. So they wanted flexible workspaces with display walls that could be adapted very quickly, and also huddle rooms, and so we started to develop quite a vocabulary of different types of workspaces with them that would be accommodated within the building. So, do you want to take that?
So the structure, sorry, pardon me. The structure of the building, as Karen said, is wood, and one of the pretty major issues was eliminating all of the, sort of this idea, okay, everything except for, we're going to make the ground floor slab out of concrete, but everything after that has plants. Some sort of, plant-based construction. So this was the biggest issue, I suppose, in that was lateral stability from a number of perspectives. A lot of wood buildings that you look at today, kind of mass timber in inverted commas, are rectangles. And the reason they're rectangles I think anyway, is because it's relatively straightforward to resolve lateral stability problems. But when you have something that's kind of fan-shaped, it becomes a more interesting challenge because you have to distribute where you have to extend to all parts of the fan to basically be able to deal with the lateral loads in different ways. You can't rely just on the cores, in other words, because you don't have cores everywhere. So this brings a certain amount of things like cross-bracing into the facades. The other aspect of that that's kind of interesting is that, you know, with a relatively distributed floor plate, you have a certain amount of vibration that needs to be dealt with, and this impacted on how we were thinking about the structural grids, because obviously it's an office building, so you're thinking about planning modules and things like that. But we're also thinking about the maximum span that we can do, kind of, let's say, affordably in wood. So the front bar, if you like, the one that's at the bottom of the page there, is a 10-meter span with no columns in the middle, which is about the limit that we could get away with in terms of having a reasonable floor-to-ceiling dimension underneath the beam. And I remember when we sent this to the, so with mass timber buildings today, the design team designs it and then it goes out to tender, and then there are any number of companies that tender for these things, not that many. And they propose something that's similar to what you tendered, but not exactly the same. And it's not exactly the same almost everywhere. So there's lots of little changes that have to happen. And I remember one of the ones that happened here was that the contractor came back with a floor-to-ceiling dimension under those 10-meter beams of 1.95 meters. So it took those kinds of things kind of come up still pretty regularly, because they're thinking about it from the point of view of what they tendered for, rather than what it is you want to build. So can you run the first video, the one that's 01? Is that possible? Yeah, thank you. So this is that core, one of the cores going up. This is obviously in the summertime, or at least at the end of the summer. So it's kind of interesting because it's a short video, it runs a few times, but there's not too many people on site. So the site was, you could go on to the next slide, please, or back to the slide. And thank you. As I said, the ground slab was cast in concrete, but underneath that, instead of pouring foundations as such, the earth was effectively rammed to make kind of what they call geopiers underneath the slab. So there's actually very little, in the end, very little concrete used in the kind of foundation parts of the building. Even the ground conditions are pretty complicated, as Karen was describing. So this is a kind of a cutaway axonometric that shows in blue the four water walls, which are at either ends of these two atria that Karen was describing. And then you see this axonometric above them. The water walls they're kind of an interesting environmental feature, because they're dealing with the fact that we've done a lot of buildings, obviously, in Ireland that are naturally ventilated. So, in some way, shape, or form, the building breathes with what's going on outdoors. And in Canada, obviously, you have temperatures that are, really, plus and minus 40. So it's obviously pretty extreme. So in order to get the building to work from an energy perspective without using mechanical ventilation or air conditioning, working with the engineers, the climate engineers, Transolar, came up with this system of, I don't know if you call it a system, but these kind of internal waterfalls that they're glass chimneys at the end of each of the atria, and you basically draw the very, very hot or very cold, depending on what time of year it is, air over them, and then distribute to add a little bit of moisture or subtract moisture, or add temperature or subtract temperature, again, depending on what season you're in. And then that's distributed horizontally through the building slab with a decentralized mechanical fans, pressure a plenum adjacent to the water walls. So these are actually steel trusses that are kind of inserted into the end of the atrium. Can you run video number 3, please? And these were going in yesterday. So I had, what was this, number 3? Okay. Well, we can look at this one. Also, maybe it's video number 4, I'm not sure. Anyway, there we go, that's it, yes. So there's the one of these trusses kind of being inserted into the structure. But I think what's interesting about this is that when you're working with, you know, a climate which is quite extreme, the level to which the building has to, what's the word, deform, but also the construction systems have to deform a bit to allow the climate flexibility to still happen without mechanical ventilation, without using fossil fuels, and all of these things end up helping us to drive the sort of carbon down. So this is being inserted or dropped into the building yesterday. The 4 of these kind of steel trusses. So if you just bump on or back to the presentation, the PowerPoint, please. We don't have to watch this to the bitter end. I don't know how it ends. I think the truss goes down or something. I hope it does. Okay. So as Karen said, Toronto, I grew up pretty close to Toronto, and we used to visit in the 70s. My parents, whenever we wanted to see, they wanted to introduce us to culture from Western New York, the beginning of the Midwest of the United States. And so it has turned into this incredibly wealthy, booming city. And I remember when we arrived there to do just at the kind of time when they were interviewing the participants in the competition, I was really shocked at the level of development, but also how incredibly unsustainable it all looked. Karen was talking about the motorways, but they're building condominiums as far as the eye can see in kind of every direction. And I think it really was, completely the opposite of, I suppose, the ethos that, we were, let's say, that was expressed in the brief that the client gave us. We found in the midst of all these, you see in the image that a few brick buildings low down. So these are all, a few of these are left. They call them brick and beam buildings. So they're basically brick boxes with timber, nail laminated slabs and timber post and beam construction. They're really beautiful buildings. Of course, they're being, kind of renovated as all the cool places to work these days, as the city kind of recognizes their value. And at the same time, there's this really strong tradition of, Karen didn't mention it, but this maple sugar shack is actually owned by the TRCA. So the client, as a client, they're not just interested because they're environmental scientists and they're planners and all that kind of stuff. They also make maple syrup, and they make beer, and they do all kinds of things that are pretty great if you're visiting them. And we were interested in the fact that they had, built this big reconstruction of the pioneer settlements that Karen was showing images of, right next to the building, which is a place where all of the kind of Canadian school kids are paraded through, to see what it was like in the early days, I suppose, of the nation of Canada. And we began to look at. We found this book that was out of print, the Building with Wood book. That's an Ontario-based publication, which is really all about how they made, how the settlers, and I'll get to the other side, the flip side of the settlement, which is the First Nations people, how the settlers used what they found there, which was basically white cedar. So Ontario is full of white cedar, and how did they use this? This is something that we looked at a lot. Like, what are the qualities of this timber? It's quite rough. It's a really interesting wood. It's quite white, and what was fascinating for us was, you saw in one of those images that Karen showed, the fact that, okay, these buildings are built, in between 1800, let's say, or 1850, this one, and they're still repaired today with the same techniques, the same wood. I was just looking at the joint in the joint that Børre showed in the house that he did, that we visited with our students, and it's exactly the same as the joint that you see in the barn up there on the left-hand side. So this, or on the right-hand side, this was a clue for us about how to think about, this is a corporate, they're a great client, but it's a corporate client. There's a construction manager. It's not a place to make experiments and suggestions that are, going to that can't be procured, publicly through a tendering process. So it's that kind of a process. So we're thinking, how can we talk to these guys about materials in a way that they already are using them and repairing their own buildings. So this is, in essence, why we decided to clad the whole building in white cedar. Shakes, which are basically cut with an axe, and shingles, which are planed a little bit. They're pretty rough. And onto this big timber frame building goes this very light timber facade, which is also clad in timber. We had, and as Karen was mentioning before, the ventilation of the building during most of the year is using the facade to, to supply the air into the office space, and the atrias are used to extract the air from the offices. So the facade also had this kind of very strong, performance environmentally, in that it was replacing the work of a mechanical ventilation system. So I think, in Ireland, it's one thing to do this natural ventilation because of the kind of pretty mild temperatures that we have here, or at least the non-extreme level of temperatures that we have, but also, the fact that it doesn't really snow and we don't have hurricanes, and, the weather is mild in lots of ways. So there's a robustness that I suppose comes with the pushing the facade and the fabric of the building to kind of really work with a kind of physiological nature that's more aggressive, and how that kind of worked through. The ravine itself is an approach to the building, so it is thought of, it has a culture of danger. People talk about the dark ravine, but they're now kind of transforming the TRCA as really changing the ravines into a place of pleasure. So there's an approach to the building that comes through the ravine. This is like an early study that we had done of this compressed corner that Karen was referring to. And then there's the side that faces Shoreham Drive and this kind of urban woodland and all of the classifications that the TRCA go through to kind of explain that. So, at a certain moment, the building's cladding steps back and the structure comes out, and there's the, anticipation of the different levels of weathering that those things are going to have, because some are shaded, some aren't. These are some pretty early studies. So, we thought that in Canada, who wouldn't have thought that we're going to build this out of Canadian timber, right? You're going to Canada, and there's 9% of the global forest is in Canada. So, the place is basically just trees. At a certain moment, that's true. As soon as you go north of Ontario, and not very far north, you're into a population of trees, which is just staggering. But you really have to look at how different that forest is from, say, the Irish forest, the Norwegian forest, the French forest, the German forest. So forests are basically political entities. They don't know this, but they're captured within their political spheres, and how they are, managed, governed, how their products make their way onto the market is as much a matter for politics and economics as it is for sustainability. I think sustainability or the whole question of carbon, certainly, when you look at what goes on in the Canadian forest, or the North American forest, I should say, because its practices are pretty widespread in the US as well, it's a really different attitude, you can imagine. When there's not that many people and a lot of trees, the trees are seen as a source of something rather than as something that necessarily needs to be renewed. On the other hand, this diagram, so you're looking at a part of Ontario, and Ontario is, actually it's interesting to see the map like this. You see the US with all the states, and then the provinces in Canada. The provinces in Canada they're all huge, and they all go north. So they all end in enormous forests. And most of them are First Nations land. So they're, before the nation of Canada was established, of course, all of this land was was where the First Nations lived. So the TRCA has and this is still the case. First Nations still control and own enormous forests in Canada, and the TRCA has a policy of supporting First Nations peoples through purchasing timber from them. Now, it's not that straightforward because there are enormous parts of Canada that are, that are not part of First Nations land, that are still huge forests. And this, I would say that not only the method of harvesting, but also the sawmills are all geared up to an industry that supplies, an enormous amount of 2x4s, a lot of paper products, many things that aren't useful for buildings. And the forests are very remote. I mean, they harvest trees with helicopters because you can't get equipment to these places. They're only accessible really at certain times of the year because of the bogginess of the land. As soon as the thaw hits, when it hits, you can't get up there. And then when it is deep winter, you have the opposite problem. You have snow. So there's a really kind of narrow period of time that they can harvest some of these trees. Which means that the industry is actually pretty unsophisticated as far as, let's call it engineered timber, or timber that you could use for building products, or timber that you could even assess the quality of. So I think that's pretty interesting in the context of the whole conversation about, well, what are the supply chain questions? There's supply chain issues in every kind of construction product, and we talk about how easy it is to build out of steel or concrete, but when you look at the supply chain, it's a very sophisticated, very well developed, and completely insane, if you break it down, supply chain, right? I mean, it makes no concrete. If you were trying to sell concrete today, you just invented this great material called concrete, it'd be a pretty hard sell because it's very complicated and expensive looking to bring onto a site. This liquid viscous material that you have to pour into a pre-made form that you're going to throw away, that is going to be filled with hand-bent bars of steel. And it sounds nuts, but but it isn't, of course. We know that. So I just think that the supply chain issues, when you look at them when it comes to timber, are equally complicated and equally, kind of bound up in politics, economics, and what's actually feasible. So it's really, so what I want to say is the structure for this building, the wood came from two places. One is Austria, the other one's Sweden, two countries, and two suppliers. And the reason for that is that when we tendered this, we tendered it to, there was a construction manager who tendered, so we didn't do the actual tendering, the construction manager did. They tendered it to all of the companies in British Columbia, North America, and Quebec, who were, the establishment, if you like, in terms of mass timber construction. And what we discovered is that their capacity was quite limited. They had already committed their, production to other buildings and other projects. And so the company that won the project is effectively a startup company called, won the timber structure part, not the whole project, just the timber structure part, is a company called Element 5. There's they got a grant from the Ontario government. There are no other mass timber, construction companies operating who have fabrication capacity, I should say. There's a lot of erection companies who in Ontario. So they got a grant from the government. They set up a factory in St. Thomas, which is just west of Toronto by about an hour. But none of it, they had ordered all of the machines to make, glulam and CLT and so on. They had hired engineers from northern Italy who were timber engineers to help them, but none of it was actually operational. So they didn't actually have any way of making anything. So they ended up subcontracting the entire job. So they bought the CLT from Stora Enso and the glulam beams and columns from Haslacher, and they assembled it with another crew who came from Quebec. So it was a pretty interesting, let's say, eye-opening experience in terms of, well, if you're really going to build with wood, in a public project where there's, a process that you don't, that is quite complex already, irrespective of whether you want to do a kind of a low-energy mass timber building, what does the reality of that look like? And I think the other thing I wanted to say is that the design process from, I mentioned earlier that when the building is effectively recalculated by the company supplying the timber because of the way that they tender it. So this process is also really interesting because, of course, it happens completely. Well, it happened during COVID, so it was remote, but it would have been remote anyway. It was just all digital, all online, basically, where you're working on a Navisworks, kind of a Revit model viewed through a Navisworks viewer, and effectively figuring out the entire building again, but this time with all the contractors participating. So it's a pretty fascinating process. I found it to be very interesting. So because everybody gets to know the entire building before they build it, every aspect, every hole that you want to drill, every kind of bit of mechanical and electrical service and so on is fully kind of figured out in this process, and it's not fun, would be one way to describe it, but dramatically different is the other way to describe it, I would say, from any other project that certainly that we've ever worked on before that involved this. Now, the other thing that I think is really interesting in terms of the supply chain question is, and I think Børre speaks about this really eloquently, where does wood come from, and what is its connection to the forest actually? So, because we were getting the wood from the EU, it's really well tracked. You can pretty much tell where you can't quite figure out what maybe part of the forest it came from, but you get a pretty good idea. And this is something that in Canada is not possible, and they're completely uninterested in it as well. So it comes with all these barcodes and so on that we had seen previously on timber projects that we were working on. It was kind of really, with all the Austrians and the kind of, let's say, Germanic intensity that flows around information and data and correctness, assumed, that would be embraced in North America. It wasn't at all. It was kind of seen as a big risk. We don't want to know too much. And I think this is also really interesting in this kind of supply chain question, because when it comes to certification and control, and when it comes to, being able to, let me say, explore the potential of a material, you're also kind of fighting this enormous, let's say, what's the word? Backwash is the way I would say it, of regulations, of systems, of processes that are quite dense when it comes to, because timber has its particular way of moving from the forests to the building site in one jurisdiction, and another way in another jurisdiction. And if those two things aren't quite the same, it can be difficult to figure out exactly what's going on. Fortunately, because this wood came from the EU, we were able to know exactly what was going on all the time. And so it arrived into this factory, and I was just describing, this is kind of what you end up with when you, I'm going to call this is one of those lobotomies that Børre was speaking about, that hole up there. It's a lobotomy for a, what do you call it, a sprinkler. Anyway, so the construction site, I was saying briefly that the slab went in. The other kind of important thing that happened were these brackets that are shear brackets, so they're basically holding the building to the ground, make sure it doesn't float away. It is actually a pretty light building because it doesn't have, much other than wood above the ground slab. It actually doesn't weigh very much. And we did an exercise with a group of students at the University of Toronto, and they had this project last semester where they were looking at the carbon content of all the mass timber projects that were happening, in North America and Europe. I think there were 9 projects. And what was really interesting about this was, and we didn't know this, was that the TRCA project was a very low carbon project. It wasn't necessarily something that we were thinking about at the beginning, but it was very low carbon because of the virtual elimination of carbon intensive materials above the ground slab. But the other side of it, I think, that is even, to my mind, more interesting and speaks to the question of the fact that one builds buildings for the long term, is that the environmental strategy and the fact that the building is, not using any fossil fuel and hardly using even any alternative energy sources to heat and cool itself in this environment really drive the carbon down about as close to zero as possible. And I think the figure that they came up with was 12 kgs of carbon per square meter per year, so it's very low. But I don't think in this process that you can take anything off the table if you have to maximize absolutely every opportunity that's out there, otherwise it won't happen. I wonder maybe, because I just have a bunch of photographs, but maybe if you could run video number 5, the last one, which is just a kind of an animation of this, and then I think I have one more video, which is number 2. So this is obviously assembling the thing. So you can see the trees that ring the site, or all this kind of woodland environment that Karen was talking about. In the distance across the way are the kind of large low-income housing projects that are on the other side of the ravine. So part of the opening that Karen was talking about is actually to that community on the other side of the ravine. This is kind of how the site looked for a very long time. And if you could run video number 2, I think, the second one that you ran, which is the last thing that I'll show you. Yeah, this one. So what the main purpose, I suppose, in trying to, let's say, to show you this is taken just a couple of weeks ago. It's less about the building and more about the site. So you can see the ravine to on the right-hand side of the image, and then you can see Toronto sort of spinning around in 360, and the contrast, I suppose, that really struck us about between the development of this huge city and all of the economic and political impetus behind that. I mean, it is it's definitely Canada's wealthiest city. It's innovation driver, if you like. It's many things, and that this little moment of the TRCA and this kind of idea that they had about trying to allow the philosophy that they have and the mission that they have around the ecology to drive a different kind of future and a different kind of development was really striking to us. But it wasn't something that we appreciated all at once. It wasn't something that we got immediately upon arriving there. It was something that slowly over time has become noticeable and has become something that you sort of think, well, if there is going to be a transition or kind of a movement away from one way of building things and one way of doing things to another way of building things and another way of doing things, it's going to take an awful lot of this. I mean, it's going to take, this is in no way, when I say this discussion that we've been having here today and all of the presentations that have been made, and the predecessor to this 3 weeks ago, I think it's extremely important, and it needs to have that kind of momentum in order to be successful and in order to kind of develop the patience that's going to be required, or that is required, to put up with and overcome all of the, I think, imperfections and problems that trying to transform a construction industry, transform how we build and what the priorities that we kind of state are important, to shift them. Okay, thank you. You could stop this video.